What if the submarine that nearly transformed the outcome of the Second World War had arrived just 6 months earlier? What if the technology that German engineers spent years perfecting had been deployed before the Allied forces had time to develop their countermeasures? These are the questions that historians still whisper about in the quieter corners of naval archives. Questions that hinge on the remarkable and haunting story of the Type T U-Boat, a vessel so advanced that it seemed to belong to a different war entirely, a different era altogether. The Type XXI was not simply another variant of the U-boats that had already prowled the Atlantic and terrorized merchant convoys throughout the war. It represented something far more profound, a complete reimagining of what a submarine could be, what it could do, how fundamentally it might alter the balance of naval power. It was, in the truest sense, ahead of its time. And yet, for all its revolutionary design and all the hopes that German High Command had invested in it, the Type 21 would arrive too late and in too few numbers to change history's course. But the shadow it cast, the possibilities it embodied, would linger long after the war had ended, influencing submarine design and naval strategy for decades to come. To understand why this submarine mattered so much, why military theorists and historians have spent generations analyzing its specifications and imagining alternate timelines, we need to step back and consider the state of submarine warfare in the middle years of the Second World War. The Battle of the Atlantic, that grueling, grinding contest between German U-boats and the combined naval forces of Britain and the Allies, had already shifted decisively. What was once a devastating German advantage in the early years of conflict had been slowly, painfully transformed into a vulnerability. The hunters had become the hunted. Sonar technology, improved convoy tactics, escort ships equipped with better detection equipment. These innovations had turned the tide against the U-boats in ways that German strategists had not fully anticipated. By 1943 and into 1944, serving on a U-boat was increasingly perilous. The survival rate for crew members had plummeted. Patrols that once promised weeks of fruitful hunting now often ended in violent, sudden destruction. Submarines were being sunk faster than they could be replaced. The whole calculus of submarine warfare, which Germany had built its strategy around, was unraveling. It was in response to this deepening crisis, this realization that conventional U-boats could no longer operate effectively in the face of Allied air superiority and naval coordination, that German engineers and naval architects began conceiving something revolutionary. They knew that the future of submarine warfare, if there was to be a future for it at all, lay in speed and in stealth. Not in the ways that previous submarines had been stealthy, moving slowly and carefully through the depths, but in the ability to move faster underwater than any surface vessel could move on the water, to slip through enemy defenses like a blade through shadow, to strike before being detected, and vanish before retaliation could be organized. The Type XXI U-Boat was designed from the very foundation with this principle in mind. Every system, every structural choice, every innovation in engine design and hull configuration was oriented toward this singular goal: to create a submarine that could outrun, outmaneuver, and outlast anything that the Allies could throw at it. If you've ever wondered how technological innovation shapes history, or how a single design choice made in a desperate moment of wartime can echo forward through the decades, then the story of the Type 21 is one that will stay with you long after sleep has taken hold. It's a narrative woven from engineering ambition, strategic desperation, and the profound irony of creating something magnificent at precisely the moment when time has run out. If you'd like to follow the complete history of the Type XXI U-Boat, from its conception in German war rooms, through the revolutionary breakthroughs that made it possible, all the way to its final, haunting significance in shaping the post-war submarine race, I'd invite you to subscribe so that this extraordinary story can guide you deeper into the night. But let us begin properly with the moment before, the crisis that made the Type 21 not just desirable, but absolutely necessary. The year is 1942, and in Berlin and in the submarine command headquarters on the French coast, German strategists are confronted with an uncomfortable truth. The U-boat fleet, which had once been the terror of the Atlantic, which had sunk ships faster than they could be built, which had nearly brought Britain to its knees in the early years of the war, is facing a problem that conventional tactics cannot solve. The Allies, you see, had learned to see in the dark. Through radar, through sonar, through aircraft equipped with searchlights that could illuminate the ocean at night and catch submarines as they attempted to surface and recharge their batteries, the Allies had fundamentally altered the nature of submarine warfare. A U-boat on the surface, charging its diesel engines and ventilating the foul air from inside the pressure hull, was now a target waiting to be destroyed. And a U-boat underwater, moving on its battery-powered electric motors, had a maximum speed of perhaps 7 or 8 knots and could operate for only a limited number of hours before it had to risk surfacing again. This was the tactical prison that German submarines had been gradually locked into, and it was becoming an increasingly deadly predicament. Every patrol became a gamble, with longer odds than the last. The crews knew it, their commanders knew it, and the admirals in Berlin knew it too. Something had to change, or the entire U-boat offensive would collapse, indeed, was already collapsing, into irrelevance and waste. The story of the Type XXI truly begins not with steel or war, but with failure. By 1942, the German Kriegsmarine found itself facing a crisis that no amount of courage or determination could overcome. The Atlantic convoy routes, those lifelines carrying food, fuel, and weapons from America to Britain, had become a nightmare for the U-boat commanders. They had started the war with such devastating promise, sinking ships by the hundreds, watching Allied merchant vessels slip beneath the cold North Atlantic waters. The tonnage seemed endless, and for a time, Germany believed it might actually starve Britain into submission through sheer attrition. But something shifted. The Allies developed new detection methods, new tactics. Radar, that invisible eye mounted on escort vessels, began seeing submarines that thought themselves invisible under the cover of darkness. Depth charges became more sophisticated, more deadly. Aircraft started patrolling the convoy routes, forcing U-boats to dive deeper, stay submerged longer, and move more slowly. The hunters were becoming the hunted, and the German submariners knew it with a certainty that grew heavier with each passing month. The loss rates climbed. In 1943 alone, nearly 40% of Germany's U-boats were sunk. The ocean, which had once seemed to belong to the Kriegsmarine, now felt like a place of exile and death. It was in this atmosphere of desperation that German naval architects and engineers began to ask themselves a fundamental question. What if we could build a submarine that was fundamentally, radically different from everything that had come before? What if, instead of trying to make the existing designs faster or more heavily armed, we reimagined the entire concept of what a submarine could be? The men who posed this question understood something crucial about underwater vessels. The old U-boats, the Type XXI and Type XXI models that had dominated the early war, were, in many respects, surface ships that could briefly submerge. They spent most of their time on the surface, using diesel engines to move quickly across vast distances. When they detected danger, they would dive, but diving was slow. A Type XXI might take 3 to 5 minutes to disappear beneath the waves, and when it was submerged, its electric batteries gave it only a few hours of decent speed before they were drained. After that, the submarine had to surface again, running its diesel engines on the surface to recharge the batteries, which meant running the risk of being spotted again, of being attacked again. It was a cycle of vulnerability that could not be overcome with the existing technology. The engineers who would eventually design the Type XXI understood that the fundamental problem wasn't just about making a faster submarine. It was about creating a submarine that could stay submerged for extended periods while maintaining reasonable speed. They dreamed of a vessel that could hide beneath the waves, that could operate as a true submarine rather than as a diving ship. And to accomplish this, they knew they would need something entirely new, a revolutionary power system that could drive the submarine through the water while it remained completely submerged, never needing to surface except for air. This dream led to the development of the snorkel, or schnorchel, as the Germans called it. The concept was not entirely new. Dutch submarines had experimented with similar devices before the war, but the German engineers refined it, perfected it, and began installing it on existing U-boats. The snorkel was a simple but elegant tube that extended above the water's surface, allowing the submarine's diesel engines to draw fresh air while the boat itself remained beneath the waves. It was not a perfect solution. The snorkel could only be used in relatively calm seas, and it was visible to patrolling aircraft if they knew what to look for. But it represented a crucial step toward a new kind of submarine, one that could operate with greater independence and less vulnerability. Yet even with the snorkel, the fundamental limitations remained. The old submarine designs, the aging Type XXI boats that Germany still relied upon, could not be transformed into what the war now demanded. What was needed was not a retrofit or an improvement to an existing design. What was needed was something entirely new. This is where the Type XXI emerges from the blueprint and the dream. In 1943, as the U-boat war reached its crisis point and Germany's naval engineers knew that conventional submarines were becoming obsolete, they began work on a design that seemed almost impossible given the constraints of the time. The boat they envisioned would be bigger, yes, but more importantly, it would be fundamentally reconceived. Instead of trying to squeeze more diesel power or more battery capacity into a familiar shape, the designers at Blohm + Voss and Germania Werft decided to build a submarine that was optimized entirely for underwater performance. Every curve, every system, every decision was made with one question in mind: how do we make a boat that is faster underwater than on the surface? How do we make a boat that can stay down and stay hidden and still move with genuine speed? The implications of this question were staggering. For nearly a decade, submarine warfare had operated according to certain tactical principles born from the reality that submarines were slower underwater than on the surface. The commanders learned to work around this weakness, to use their speed on the surface to race into position, then to dive and stalk their prey. The entire doctrine of U-boat tactics was built on this understanding, but the Type XXI threatened to upend all of that. It promised to reverse the equation entirely, and as the war situation grew more desperate for Germany, as the losses mounted and the old tactics failed more consistently, this new submarine began to seem less like a luxury and more like a necessity for survival. The first glimpses of the Type XXI in design meetings and technical specifications would have seemed almost fantastical to many of Germany's traditional naval officers. This was not going to be a slightly improved version of the Type XXI. This was going to be something so different that it seemed to belong to a different era altogether, perhaps to a future that Germany might never live to see. Yet the work began, driven by desperation, by technical brilliance, and by the faint hope that perhaps, just perhaps, one revolutionary innovation might still turn the tide. The engineering specifications that made the Type XXI revolutionary began, in many ways, with a deceptively simple observation. By 1942, the German Naval Command had come to understand something that Allied strategists had grasped much earlier. The submarine of the future would not be a vessel that operated primarily on the surface, diving occasionally to escape detection. Instead, it would be an underwater craft that happened to surface when necessary. This fundamental shift in philosophy would reshape everything from hull design to propulsion systems to the very bones of the boat itself. Previous U-boat designs, stretching back through the Type XXI and earlier models, had been optimized for a kind of compromise existence. They moved faster on the surface than submerged, which meant their captains faced a constant tactical dilemma: hunt for convoys on the surface at high speed, or creep through the depths at a plodding pace in search of prey. The best strategy was often to race ahead of a detected convoy on the surface, dive into position, and wait. But this approach had grown increasingly dangerous as Allied escort vessels multiplied and radar technology advanced. What once seemed like a viable tactic was becoming a death sentence. Helmut Volter, a brilliant German engineer whose name would become synonymous with experimental propulsion, had already begun exploring what might happen if a submarine could move at significant speed underwater. His ideas involved hydrogen peroxide as a fuel, creating a kind of hybrid system that promised speeds of up to 25 knots submerged, speeds that seemed almost fantastical to the conventional minds of the German Admiralty. Yet the Type 21 was not built around Walter's revolutionary engine. Instead, it would carry a more conventional diesel-electric system, though one that had been refined and reimagined in ways that were genuinely innovative. The secret to the Type 21's underwater performance lay not in any single miraculous technology, but in 1,000 small refinements accumulated through meticulous engineering. The hull itself was redesigned around the concept of streamlining, where earlier U-boats had bristled with external fittings, gun platforms, and features that created drag. The Type 21 was smoothed almost into a torpedo shape itself. The conning tower was reduced in profile, fairings covered anything that protruded. Even the periscope housings were contoured to minimize resistance as the boat moved through water that was, for all intents and purposes, as resistant to motion as a crowded room is to sound. Beneath this sleek exterior lay a battery system of staggering capacity. The Type 21 carried roughly double the battery storage of a Type XXI, crammed into compartments that ran along the length of the hull like a submarine's second skeleton. These were not the primitive lead-acid cells of earlier boats, but rather a more advanced formulation designed to deliver power more consistently and to accept the kind of rapid charging that would be necessary if the boat was going to maximize its tactical advantage. Imagine, if you can, the interior of a World War II submarine, already cramped beyond what modern sensibilities could easily tolerate, packed even more tightly with the dense weight of electrical storage. Every cubic inch was precious, every kilogram counted. The diesel engines themselves, when the boat was operating on the surface or snorkeling near it, were coupled to a sophisticated electrical system that could charge those massive batteries at unprecedented rates. This was the rhythm of the Type 21's existence: surface or snorkel to charge, submerge and run on battery power, perhaps for many hours, at speeds that would have seemed impossible in submarines just 3 or 4 years earlier. The designers had essentially created a vessel that could dash underwater the way a conventional U-boat would dash across the surface, then settle into a patient, quiet hunt when prey was detected. The internal architecture reflected this new operating philosophy as well. The Type 21 was one of the first submarines designed from the outset to accommodate diesel-electric machinery that could function in ways the human operators would find genuinely different from what they had known. Earlier boats had been retrofitted, modified, adapted. This boat was born for its purpose. The engine room was deeper inside the hull, better protected. The crew spaces, while still impossibly tight by any modern standard, were arranged with better ventilation in mind. Not comfort. Submarine design and comfort have always been irreconcilable concepts, but rather the kind of functional arrangement that would allow 8 men to maintain their awareness and sharpness during a grueling patrol. And the sensors. Here too, the Type 21 represented an evolution. It carried a new sonar array that was considerably more sophisticated than what previous boats possessed. The operators would be able to detect distant targets more clearly, to track moving vessels with greater precision, to understand the acoustic landscape around them as they drifted through the deep like hunters in an invisible forest. This was particularly significant given that by 1944, Allied convoy formations had learned to use sound themselves, active sonar, the ping of ultrasonic waves, to search for submarines. The German designers recognized that their boats would need to listen and understand what that listening meant. What the Type 21 represented, in its totality, was a kind of coming-of-age moment for submarine design itself. Earlier boats had been evolutionary descendants of surface ships that happened to be able to submerge. The Type 21 was evolutionary descendant of the idea of the submarine itself. a craft that was, at its core, meant to exist beneath the waves. The fact that it could surface and move about in air was almost secondary, and this was perhaps the most unsettling aspect of its design from the perspective of the Allied navies that would eventually face it. The rules of engagement, the tactical assumptions that had governed submarine warfare, would need to change. The trials and early operations of the Type 21, once the boats began to leave the yards in late 1944 and into 1945, revealed something extraordinary. Experienced U-boat captains and crews, men who had spent years in earlier boats, found themselves commanding vessels that felt genuinely different. The handling was more responsive. The underwater performance was intoxicating by the standards of the time. Some captains reported feeling almost like they were piloting a new kind of creature, one that belonged to the deep, in a way that no previous submarine truly had. Whether these reports were entirely accurate or somewhat colored by the excitement of commanding cutting-edge machinery, the effect was the same. The boats worked. They worked in ways that demonstrated, conclusively, that German engineering could still produce innovations, even as the Reich itself was crumbling. The designers of the Type 21 understood something that had eluded many German engineers until far too late in the war. They recognized that the traditional U-boat, that surface raider that dove when threatened, was becoming obsolete. The very tactics that had made submarines so devastating in the early years of the Atlantic campaign were now a liability. Allied aircraft, long-range bombers, and escort vessels had grown too numerous, too vigilant, and far too practiced in hunting their prey. A submarine that spent half its time on the surface was, in many ways, a submarine that was already half defeated. So the engineers at the Blohm & Voss shipyard in Hamburg, along with their colleagues scattered across occupied Europe, began to imagine something radically different. What if a U-boat could remain submerged almost indefinitely? What if it could cruise beneath the waves at speeds that rivaled or even exceeded those of surface vessels? These were not questions born from idle speculation. They came from battlefield desperation and a cold, clear assessment of how the war was shifting. By 1943, the German Kriegsmarine had already begun to lose the Battle of the Atlantic. The newer escorts, the improved radar, the coordinated convoy systems, all of these had turned the tide. Something transformative was needed, or the U-boat fleet itself would become little more than a museum of lost causes. The technical revolution that the Type 21 embodied began with a deceptively simple principle. The designers decided to optimize the hull, not for surface performance, but for underwater travel. Previous U-boats had been shaped more like surface ships that happened to be able to submerge. Their hulls were relatively narrow and elongated to reduce water resistance when running on the surface. But water resistance and air resistance operate on very different principles. What works on top of the waves doesn't necessarily work beneath them. The Type 21 was designed from the keel up to be a submarine first and foremost. Its hull was broader, more hydrodynamic when viewed from the perspective of underwater movement, and arranged so that maximum volume could be packed into the pressure hull without compromising safety or structural integrity. This architectural shift had profound implications. More volume meant more battery capacity, and battery capacity, in the underwater age of diesel-electric submarines, was everything. A larger battery could drive the boat faster for longer, or maintain a slower, more efficient cruising speed for days and days without surfacing. The Type 21 carried two massive battery compartments, one forward and one aft, containing a total of 252 cells. To put this into historical context, the Type Vic, the workhorse of the German U-boat fleet, carried only 124 cells. The Type 21 essentially doubled the electrical power available to the submarine. That difference, seemingly mathematical and abstract, meant the difference between a submarine that had to surface after a day and a half underwater and a submarine that could vanish beneath the waves for up to 5 or 6 days at a time. But there was a secondary innovation that made this extended underwater endurance truly revolutionary. The Germans developed what they called The schnorchel, though the Dutch had originally invented a similar device years earlier. This was a breathing tube that could be extended to the surface while the submarine remained submerged at periscope depth. As long as the schnorchel remained above the waterline, diesel engines could continue to run and to charge the batteries. The submarine was no longer tethered to the surface by the need for fresh air and engine fuel. It could cruise at shallow depth, operating under diesel power, while remaining virtually invisible to the naked eye. An observer on the surface might see a small pipe jutting above the waves, but from any distance, in poor visibility, in the chaos of patrol, it might as well have been invisible. The schnorchel transformed the submarine's operational profile entirely. No longer did it have to choose between surface vulnerability and battery depletion. These mechanical and electrical innovations were complemented by a third revolutionary system. The Type XXI was designed to carry a new kind of torpedo, the Zaunkönig, which used acoustic homing technology to track and strike enemy ships. Traditional torpedoes required either direct aim or a calculated prediction of the target's course. But the Zaunkönig could hunt. It could listen to the sound of a ship's propellers and adjust its path accordingly. A Type XXI submarine could fire its torpedoes and then immediately dive deep and go silent, evading counterattack while the weapons did their work. The tactical implications were staggering. The old way of submarine warfare, quick ambush followed by hasty retreat, was yielding to something more sophisticated, more dangerous, and more survivable. The pressure hull of the Type XXI was also revolutionary in its structural design. Rather than the traditional figure-8 shape that had dominated previous submarines, the Type XXI employed a simplified circular cross-section. Circles, when pressurized, distribute force evenly and require less material to withstand equivalent stress. This allowed the engineers to build thicker, stronger walls while keeping the overall weight manageable. The submarine could dive deeper than its predecessors and withstand greater pressure without structural failure. The diving depth was approximately 150 meters for routine operations, with a maximum theoretical depth of around 200 meters. For a submarine in the 1940s, this represented a significant tactical advantage. It meant deeper refuge from depth charges and a greater volume of ocean to exploit. Perhaps most tellingly, the Type XXI had a dramatically improved power-to-weight ratio. Its diesel-electric engines could generate more power than larger, heavier submarines, yet the boat itself was relatively compact. When running on battery power, the Type XXI could achieve speeds of around 16 to 17 knots, faster than most escort vessels of the era could travel in reverse. When running submerged on batteries at lower speeds, say around 5 or 6 knots, the endurance extended to nearly 5 days. This meant a submarine could creep into a convoy's patrol area, wait for opportunity, strike with deadly efficiency, and then either hide or retreat before retaliation could be organized. The cumulative effect of all these innovations was a submarine that represented a fundamental break with everything that had come before. Earlier boats were compromises between surface and underwater performance, caught in the middle, masters of neither realm. The Type XXI was a genuine submarine, optimized for invisibility and violence beneath the waves. It was as though the undersea had finally been gifted a true citizen, a creature designed from first principles to thrive in that crushing, lightless world. To many observers at the time, particularly within the German Naval Command, this boat seemed to offer a possibility that had seemed foreclosed. Perhaps, after all, the U-boat campaign could be revived. Perhaps the Atlantic could once again become a German lake, sealed off from Allied shipping, starving Britain of the supplies it needed to continue the war. It is difficult to overstate how compelling this vision must have seemed to a nation that was losing on every front, where every weapon that could turn the tide became a subject of obsessive hope and strategic fantasy. And so the engineers at the German naval yards began their work in earnest, knowing that time itself had become their greatest enemy. The Type XXI represented not merely an evolution of submarine design, but something far more fundamental, a complete reimagining of what an underwater vessel could be. Previous U-boats, you see, were fundamentally surface ships that could dive. They spent most of their operational lives above water, using diesel engines to patrol and hunt, submerging only when threatened or when making an attack. But the Type 21 inverted this entire philosophy. Here was a boat designed to live beneath the waves, to treat the ocean depths not as a refuge, but as its natural home. The innovation that made this possible was the adoption of a revolutionary propulsion system. Rather than relying solely on diesel engines, the Type XXI would be equipped with what the Germans called the schnorchel, or snorkel, a breathing tube that allowed the submarine to operate its diesel engines while remaining submerged. This was not entirely new. Other nations had experimented with snorkels, but never had they been integrated so completely into a submarine's design philosophy. Coupled with a massive battery system, larger than anything previously attempted, the Type 21 could theoretically remain underwater for days at a time, traveling at speeds that seemed almost miraculous for a submarine of that era. Where earlier U-boats might manage 4 or 5 knots when submerged, the Type 21 could approach 8, even 9 knots, speeds that made them competitive with many of the escort vessels hunting them. The hull design itself spoke to the sophistication of German engineering during those final years of the war. Every line, every curve had been tested, refined, tested again. The streamlined form owed much to theoretical hydrodynamic studies, but also to something almost intuitive. The designers seemed to understand, before the mathematics could fully prove it, that a submarine moving through water benefited from the same aerodynamic principles that made aircraft efficient through air. The boat was longer and more slender than its predecessors, the conning tower redesigned to cut through water like a knife, rather than resist it like a wall. This was evolutionary progress made visible in steel and rivets. But beneath these external elegancies lay perhaps an even more significant achievement: the automation and optimization of internal systems. Previous submarines were cramped, uncomfortable spaces, where men lived in conditions that would be considered inhumane in almost any other military context. The Type 21, by contrast, incorporated innovations in air purification, in heating systems, in the arrangement of components that suggested the designers had actually thought about what it meant for human beings to spend extended periods in a metal tube beneath the ocean. The crew spaces were larger, relatively speaking, the working areas more efficiently arranged. Ventilation was improved. These might seem like minor mercies, yet they represented a fundamental shift in how submarine design was conceived. A better rested crew was a more effective crew, and the designers understood this in ways that their predecessors had often overlooked. Consider for a moment the engineering challenge this all represented. The specifications called for a boat that could submerge faster than any other submarine in existence, accelerate more quickly, turn with greater agility, and remain underwater for longer periods while traveling faster than the enemy expected. Each of these demands pulled against the others. Greater speed underwater required a larger, more powerful battery and diesel engine, which meant more weight, which meant a larger hull to maintain buoyancy. A larger hull required more steel, more rivets, more welds, and every one of those connections was a potential point of failure when the boat dove deep. Streamlining the hull for hydrodynamic efficiency meant losing the massive gun deck that older U-boats had carried, the physical space where crew could gather, the visual symbol of a warship. The designers had to make choices, to prioritize, to ask themselves constantly what mattered most, what was truly essential to the mission. The mission, of course, was to break the stranglehold that the Allies had placed upon German commerce and supplies. The Atlantic had become something close to a German Ocean in the early years of the war, where U-boats operated almost with impunity, sinking merchant vessels faster than the Allies could build them. But by 1943, as we discussed earlier, the tide had begun to turn irreversibly. The Allies had developed new radar, new sonar, new tactics, and most importantly, they had developed the will and the resources to flood the Atlantic with warships and aircraft. The U-boat fleet had become a service of martyrs. Young men, many of them not yet 25 years old, were sent to sea, knowing that their chances of surviving the war were minimal, perhaps no better than 1 in 3 or 1 in 2. Some of those who commanded these boats, men like Wolfgang Luth, one of Germany's greatest U-boat captains, could rationalize this sacrifice by pointing to the tonnage sunk, the cargoes destroyed, the delays imposed upon the Allies' grand strategy. But the mathematics of attrition were inexorable and cruel. The Type XXI was designed, then, as a response to desperation, not the desperate flailing of a beaten enemy, but rather the focused desperation of engineers and designers who still believed that technology, wielded brilliantly, might yet change the equation. If they could produce a submarine so fast, so maneuverable, so capable of remaining hidden that it could strike at the convoys and then disappear into the depths before the escorts could respond, might that not reset the balance? Might the Allies not find themselves forced to divert enormous resources to a renewed submarine threat? Might the strategic situation not shift, at least enough to buy time for other German weapons systems, the jet aircraft, the new weapons being developed in secret, to come into play? It was a hope built on engineering excellence, and it was not entirely unreasonable, but like many German hopes in those final years, it would founder upon the rocks of production, deployment, and above all, the simple mathematics of industrial capacity and time. The machinery of German innovation, so formidable in those years, had begun to turn toward a single obsession: how to reclaim dominance beneath the waves. By the early months of 1943, the Battle of the Atlantic had shifted decisively against the Kriegsmarine. The wolf packs that had prowled so fearlessly through convoy routes were now being hunted with improving radar, with aircraft carriers dedicated to their destruction, with sonar systems that grew more sensitive by the month. Germany's conventional U-boats, the types Viek and IXC, that had served with such lethal efficiency, were becoming increasingly vulnerable. Their maximum underwater speed remained modest, no more than 8 knots when submerged, and they could only remain below the surface for brief periods before their batteries demanded they surface to run their diesel engines and recharge. This fundamental limitation haunted the German Naval Command. A submarine forced to surface was a submarine exposed, and exposure meant death. It was Admiral Karl Dönitz himself, the man who had orchestrated the Wolfpack tactics, and who understood perhaps better than anyone the shifting mathematics of submarine warfare, who recognized the stark reality: conventional U-boats could no longer operate in the North Atlantic without suffering catastrophic losses. The Allies' anti-submarine capabilities had matured. Radar could detect a periscope at night. Aircraft with depth charges could hunt a surfaced boat across open water. The technological advantage that Germany had possessed for so long was evaporating like morning mist over cold northern seas. And so began the urgent search for something revolutionary, something that would fundamentally alter the nature of underwater combat. Could a submarine be designed that could remain submerged indefinitely, moving at speeds underwater that matched or exceeded what surface ships could achieve in normal conditions? Could such a vessel be built before the war itself ended? These questions drove the engineering sections of the German Navy and the designers at shipyards across the Reich. The concept that emerged was radical for its time, perhaps even more radical than the engineers themselves fully appreciated. Instead of the conventional diesel-electric arrangement, where engines powered the boat at the surface and electric motors drew from batteries when submerged, the new design would utilize the Type XXI hydrogen peroxide turbine system, a propulsion method that had been developed through earlier experimental boats. The hydrogen peroxide, a highly concentrated chemical solution, would be catalyzed through a special chamber where it would decompose into steam and oxygen at tremendous pressure. This superheated steam would then drive a turbine, which in turn would power a propeller, all while the boat remained completely submerged. The advantages were profound. No need to surface to run diesel engines. No need to expose a conning tower to enemy radar. The boat could cruise underwater at speeds that would have seemed impossible only months before. Some projections suggested underwater speeds of 17 knots or more, compared to the 8 knots that conventional U-boats could manage. Imagine the tactical implications of such a capability. A submarine that could maneuver like a surface ship while remaining invisible beneath the ocean. A vessel that could pursue and evade with freedom previously unimaginable. Yet this marriage of ambition and chemistry was not without its perils, and here begins one of the darker threads in the Type 21's story. Hydrogen peroxide, especially in the concentrated forms required for this application, is an extraordinarily unstable substance. It demands precise handling, specialized storage, and absolute purity in its chemical composition. Any contamination, any exposure to the wrong materials, any temperature fluctuation could trigger catastrophic decomposition. The engineers knew this. They understood the risks. But the war was grinding toward its inevitable conclusion, and desperation can erode even the most careful caution. The decision was made to proceed. The Type XXI would follow later as a larger variant, but the Type 21 would be the workhorse, the submarine that would be mass-produced, the boat that would turn the tide. Design drawings began to emerge from the offices of the Germaniawerft and other shipyards in 1942 and early 1943. The first keel was laid in the summer of 1943. Within months, the dockyards across Germany were buzzing with activity as the construction of what many believed would be the war-winning weapon accelerated with almost frantic urgency. But building submarines at scale, even with the most sophisticated designs, requires time, materials, skilled labor, and an industrial base that is itself not crumbling under bombardment. Germany's situation on all these fronts was deteriorating rapidly. The Allied bombing campaign was intensifying. Factories were being relocated, dispersed, driven underground. Shipyard workers were being conscripted for military service. Materials that had once been readily available were now scarce or rationed. The dream of mass-producing dozens of Type 21 submarines per month proved almost immediately impossible. Instead, production crawled forward, each boat requiring countless man-hours of specialized work, each vessel representing an enormous investment of resources that could scarcely be spared. By the spring of 1944, only a handful of Type 21 boats had been completed, and their combat readiness remained uncertain. They had not yet been tested in actual operations. No one knew if the hydrogen peroxide turbine system would function reliably under wartime conditions. No one knew if the boats could truly achieve the speeds their designers promised, or if they would instead prove to be experimental platforms that consumed resources without delivering results. The question that hung over every dockyards and every design office was both simple and agonizing. Had this technological gamble come too late? And was Germany betting its last reserves of industrial capacity on a weapon that might arrive when there would be no one left to operate it? By the spring of 1943, the German Naval High Command had already begun to sense that the age of the traditional U-boat was drawing toward a close. The surface submarine, that predatory wolf that had prowled the Atlantic and terrorized Allied convoys for nearly 4 years, was becoming increasingly vulnerable. Radar technology, improving steadily in the hands of the British and American navies, had fundamentally altered the hunter-hunted relationship beneath the waves. Where once a U-boat captain could surface under cover of darkness and remain relatively invisible, now aircraft equipped with centimetric radar could detect even a small conning tower from miles away. The casualties among the U-boat fleet were mounting with a terrible arithmetic that no amount of German industrial determination could reverse. In Berlin, Admiral Karl Dönitz and his technical advisors understood with crystalline clarity that if Germany was to maintain any credible submarine threat in the years ahead, they would need to build something entirely new. Not a refinement of existing designs, but a fundamental reimagining of what a submarine could be. The question that drove their thinking was both elegant and urgent. What if a U-boat could remain underwater for days, even weeks, without ever needing to surface to snorkel? What if it could move through the depths at speeds that conventional submarines could never achieve? What if it could outrun its pursuers rather than hide from them? These were not flights of fancy, though they seemed almost fantastical given the industrial realities of wartime Germany. They were expressions of a desperate necessity. The German Navy had already invested enormous resources into what they called the schnorchel system, a breathing tube that allowed diesel engines to run while the U-boat remained submerged, just meters below the surface. It was an ingenious solution to one problem, but it created another. A submarine using a snorkel was still essentially a surface ship, disguised as a submersed one. It moved slowly. It was still vulnerable to detection, and it could not stay submerged for very long without exhausting its battery reserves and being forced to surface once more. What Dönitz and his engineers needed was a submarine that would truly belong to the underwater world, not merely visit it. They needed the Type XXI. The conception of the Type XXI began in earnest in 1942, though the seeds had been planted earlier through discussions and theoretical studies. The chief designer responsible for bringing this vision into physical form was a brilliant and innovative naval engineer named Helmuth Wagner. Wagner understood that building a faster underwater submarine required solving several interconnected problems at once. The first was hydrodynamic. A traditional U-boat had been designed with its exterior shape dictated largely by the need to accommodate a gun turret on its deck, habitability for the crew, and the practical requirements of surface operation. But if a submarine was going to remain submerged for extended periods, the old design logic became obsolete. The hull needed to be streamlined, tapered, almost teardrop-shaped when viewed from above. Every protuberance, every rough edge, every feature that protruded beyond the hull needed to be minimized or eliminated entirely. The gun turret, which had once been a point of pride on U-boat designs, became a liability. It created drag. It complicated the hull. The Type XXI would therefore be the first major German submarine design to abandon the deck gun almost entirely, relying instead on its torpedoes as its sole armament. This was a philosophical break with tradition, but it was also a practical acknowledgement of a new reality. A modern warship no longer needed a gun to be lethal. The second major challenge was propulsion. The diesel engines that had powered earlier U-boats were efficient on the surface, yes, but their efficiency dropped dramatically when running on snorkel power. What Wagner and his team needed was an entirely different approach to underwater propulsion. The answer, they believed, lay in the development of what was called the Walther turbine, an experimental closed-cycle engine that burned hydrogen peroxide and could theoretically generate tremendous power without requiring access to atmospheric oxygen. However, this technology remained deeply experimental and problematic. The hydrogen peroxide was corrosive, dangerous, and volatile. Several German submarines equipped with Walther engines had experienced catastrophic failures, including explosions that killed their entire crews. By the time the Type XXI was being designed, it was becoming clear that while the Walther turbine represented the theoretical future, it was too unreliable for immediate production. Instead, Wagner's team made a different decision, one that reveals something important about German engineering pragmatism in this period. They would equip the Type XXI with a conventional diesel-electric propulsion system, but they would dramatically expand the battery capacity. Early U-boats carried batteries sufficient to provide perhaps 8 hours of high-speed underwater operation, maybe 12 or 14 hours at lower speeds. The Type XXI would carry batteries so large and so numerous that they could provide 30 hours or more of submerged cruising at high speed. To accommodate these vast battery arrays, the internal volume of the submarine had to be substantially enlarged, which meant the hull itself would be considerably bigger than previous models. A Type XXI U-boat, the most common German submarine of the war, displaced about 770 tons when submerged. The Type XXI would displace approximately 1,621 tons. This was a leap toward a fundamentally different class of vessel. Think about what this represented in concrete terms. A Type XXI could dive in the morning, travel underwater at speeds that would have been impossible for earlier submarines, remain submerged through the entire day and into the following morning, and never once show itself to the surface or extend a snorkel. The Type 21 represented the true submarine, the craft that had always been the dream of submarine designers since the very earliest experimental vessels of the 19th century. A machine that lived in the water, not merely visited it. The technical specifications of the Type 21, once finalized, were striking. It was approximately 113 meters long, with a beam of 10 meters, sleeker and more streamlined than earlier designs. Its maximum submerged speed was officially rated at approximately 17 knots, though some sources suggest that in controlled trials it may have achieved speeds closer to 18 knots. This was, at the time, faster than many destroyers could travel, and far faster than any anti-submarine vessel in the Allied Navy could match while remaining on the surface. The implications of this speed advantage were profound, and they had clearly not escaped the attention of German strategists. A submarine that could outrun its pursuers was no longer relegated to the role of ambush predator. It could become something more like a wolf pack that could choose when and where to engage, and could escape if the engagement went badly. But speed and endurance were only part of what made the Type 21 revolutionary. The Germans also invested heavily in improving the submarine's combat capabilities. The torpedo tubes were arranged in a new configuration, with 2 sets of 6 tubes each, allowing for rapid launching of multiple weapons in quick succession. The fire control system was upgraded, incorporating lessons learned from years of submarine warfare in the Atlantic. And the submarine was equipped with new sonar and detection equipment designed to identify and track targets in the underwater environment more effectively than previous models had been capable of. Perhaps most significantly, the Type 21 introduced the first examples of what might be called automated or semi-automated systems for submarine operation. Earlier U-boats required constant, active crew involvement in virtually every aspect of the boat's operation. They were laborious to pilot, exhausting to command, and prone to the kind of human errors that accumulated in the high-stress environment of extended patrols. The Type XXI incorporated hydraulic systems and mechanical controls that reduced crew workload and made the submarine easier to operate at depth. This was not automation in any sense that a modern observer would recognize, but by the standards of 1943, it represented a significant step forward. The design process for the Type XXI, once begun in earnest, moved with remarkable speed. This was partly because German designers were able to draw on the accumulated experience of building hundreds of U-boats over more than a decade. They understood submarine design as few nations in the world did. But it was also because Dönitz and the High Command understood with increasing desperation that time was running short. The Allies were gaining in all theatres, and if Germany was going to field new weapons systems that could change the strategic balance, they had to be fielded soon, not in some distant future. By late 1943 and early 1944, the first Type 21 submarines were being laid down in German shipyards. The construction was distributed across several yards, partly for redundancy, and partly because no single yard had the capacity to absorb the entire production load. And here we arrive at one of the tragic ironies of German arms development in the final years of the war. The Type 21 was, in many ways, an engineering marvel. It was genuinely innovative. It pointed toward a future of submarine warfare that the Allies would spend decades trying to catch up to. Yet, by the very time it was beginning to enter production, Germany's capacity to wage war was beginning its final, inexorable collapse. The development of the Type 21 represented something altogether different from what had come before, and the German naval engineers understood this at their very core. Where earlier submarines had been surface vessels that could dive, the Type 21 was conceived from the beginning as a true underwater craft, one that would spend most of its operational life beneath the waves rather than cutting across them. This fundamental shift in philosophy would ripple through every dimension of the boat's design, from the shape of its hull to the arrangement of its machinery deep within. The the hull form itself became a subject of meticulous study and refinement. The engineers, working in the vast design offices of the Germania Werft and other yards, understood that water resistance increased dramatically with speed, and that traditional submarine shapes, which had always been something like a flattened cylinder with a conning tower bolted on top, created unnecessary drag and turbulence. So they began to experiment with something more radical, a hull that was nearly circular in cross-section, one that could knife through the water with minimal disturbance. The lines of the Type 21, when viewed from above or the side, had a certain elegance to them, a purposefulness that suggested function had been the only consideration in its creation. Inside that hull, the arrangement of systems took on new complexity. The diesel engines that previous submarines relied upon for surface travel could not be simply scaled up and made more powerful. The engineers had to think about battery capacity in ways that no submarine designer had quite needed to before. A boat that wanted to remain submerged for extended periods needed enormous electrical storage, and that storage had to be distributed throughout the vessel in ways that wouldn't compromise structural integrity or crew safety. The Type 21 carried 120 metric tons of batteries, roughly double what earlier German submarines had carried, and these batteries occupied substantial portions of the hull beneath the crew's living spaces. The machinery arrangement also reflected a crucial innovation. The Type 21 was designed with what was essentially an early schnorchel system in mind, though the term itself was still evolving. This breathing tube, which could extend from the submarine to the surface while the boat remained submerged, allowed the diesel engines to operate underwater without the crew being poisoned by exhaust fumes. Picture, if you will, the mechanics of this. A tube running up through the conning tower, fitted with valves and safety mechanisms, allowing fresh air to flow down to the engines and exhaust gases to flow back up and out. It was a seemingly simple concept, yet it required precise engineering to prevent water from rushing down the tube during wave action, and to ensure that the pressure differentials within the boat remained manageable. But perhaps most remarkably, the Type 21 introduced a concept that would later become standard in submarine design, the Walter turbine, or at least the intention to incorporate it. The Walter turbine was a closed-cycle propulsion system that used a specially formulated hydrogen peroxide fuel to generate oxygen without needing to surface or even extend a snorkel. In theory, a submarine equipped with such an engine could remain submerged at high speed for hours, with no need for diesel, no need for batteries to be depleted by sustained high-speed running, and no electromagnetic signature from surfacing or extending a snorkel. The Type 21, as originally conceived, would have carried both the traditional diesel-electric system and a Walter turbine, making it a hybrid vessel of extraordinary capability. The crew spaces within the Type 21 tell their own story about the priorities of wartime design. Where comfort had once been a consideration, the older Type 9s, for instance, had featured small crew cabins and reasonably arranged galleys. The Type 21 squeezed every possible inch into operational systems and equipment. The men who served aboard these boats would have found themselves in an even more confined environment than their predecessors, sleeping in shifts in bunks that were often barely wider than a man's shoulders, moving through narrow passageways where two sailors could scarcely pass each other. Yet this cramped arrangement was deliberate. It meant more space for batteries, more room for the revolutionary systems that would make the boat lethal. How remarkable it is that in the midst of a losing war, German industry still found the resources and the ingenuity to pursue such radical innovation. The decision to build the Type 21 in large numbers represented a kind of technological gamble, a belief that if enough of these boats could be produced and deployed, they might reverse the tide of the submarine war that had turned so decisively against Germany. The first keel was laid in 1942, but the boat would not be completed and trials begun until late 1943. Between conception and operational readiness lay not months but years, during which the strategic situation shifted with relentless momentum. The production strategy itself was revolutionary for its time. Rather than building the entire submarine in one location, the German yards decided to construct the Type 21 in sections that could be assembled later. These prefabricated sections would be made at different yards across Germany and then transported to assembly points where the hull would be welded together. This distributed manufacturing approach, which sounds mundane to modern ears, was actually quite daring for the 1940s. It meant that specialized yards could focus on building engine rooms or torpedo compartments with maximum efficiency, rather than each yard attempting to construct an entire boat. Some 60 different suppliers contributed parts and components to the Type 21 program, a testament to the scope of coordination required. Yet this very complexity, this pursuit of revolutionary capability and manufacturing innovation during wartime, contained within it a profound vulnerability. The moment that any part of the system faltered, whether through damage, shortages, or design problems that only manifested during trials, the entire program could suffer cascading delays. And as the war situation deteriorated, the Allies grew ever more focused on disrupting German industrial capacity and the movements of materials between the scattered manufacturing centers. What had seemed like a clever solution to production capacity problems could easily become an Achilles heel if the transportation network was targeted or disrupted. The designers and engineers who oversaw the Type 21 program were working under constraints that would have seemed impossible just a few years earlier. Materials were growing scarce, skilled workers were being pulled toward frontline service or other war industries. The constant threat of bombing raids meant that production had to be dispersed and concealed. Yet still, month after month, the submarines took shape. Still, the extraordinary dream of a new generation of underwater warships proceeded forward, even as the older models continued to patrol and fight and sink beneath the waves, their crews dying in the cold Atlantic waters. The engineers and designers who had poured their lives into the Type 21 project understood something that many military planners of the era had yet to fully grasp. The submarine of the future would not be a surface vessel that occasionally submerged, but rather a creature of the deep that might only briefly touch the air. This fundamental shift in thinking required them to reimagine nearly every system aboard the boat, from the moment a young sailor stepped through the hatch until the day he might step out again, perhaps weeks hence without ever seeing daylight. The power plant that would drive this new submarine represented perhaps the most significant technological leap. Rather than relying on diesel engines for surface propulsion and battery-powered electric motors for submerged running, the Type XXI incorporated something quite revolutionary for its time, the schnorchel system, which allowed the diesel engines to operate while the boat remained beneath the surface. The principle was elegantly simple, even if the execution proved fiendishly complex. A tube extended upward from the submarine's pressure hull to the surface, drawing in fresh air, while a parallel tube expelled the diesel exhaust back into the atmosphere, all while the boat itself remained submerged and invisible to enemy lookouts. Can you imagine the psychological weight lifted from the minds of those commanding officers who might finally run their main engines without surfacing to recharge their batteries? Yet the schnorchel was not a German invention, though the engineers refined it to extraordinary effect. The Dutch had experimented with the concept years earlier, and the Japanese had their own variants, but it was the desperate urgency of German naval command in the final years of the war that drove the Type 21 design team to perfect it to a degree that made the technology practically transformative. Once a boat surfaced to schnorchel, of course, it remained vulnerable to radar detection, and this remained an eternal tension in submarine design, the need to recharge batteries and refresh air versus the constant threat of enemy aircraft and escort vessels. The schnorchel did not entirely solve this problem, but it dramatically reduced the time a submarine needed to spend on the surface, and in the calculus of modern naval warfare, a reduction in exposure time could mean the difference between returning home and being sent to the bottom of the ocean. The hull design itself reflected years of empirical research and theoretical refinement. The Type 21's hull was not merely a larger version of earlier boats. It incorporated lessons learned from decades of submarine development. mingled with wholly new engineering approaches. The pressure hull, that innermost steel cocoon that held the men and machines safe against the crushing weight of the ocean, was shaped to reduce hydrodynamic drag at high speeds. The ballast tanks and fuel tanks were arranged with meticulous care to ensure stability and trim, those subtle aspects of submarine handling that meant the difference between a boat that was a pleasure to command and one that was exhausting and dangerous. The streamlined tower, which housed the periscopes and observation equipment, was itself a marvel of compromise between functionality and the relentless physics of fluid dynamics. One might wonder whether the designers ever slept easy at night, knowing that their decisions were literally matters of life and death. Every rivet, every weld, every joint in the pressure hull had to meet standards so stringent that many could not have been verified with the testing equipment available at the time. The engineers worked largely from theory and intuition, from the accumulated knowledge of hundreds of submarine designs, and from the frightening reality that mistakes in their calculations could mean water pouring through a hull breach, filling compartments with seawater in moments, drowning the entire crew at depths where no rescue was possible. The interior arrangement of the Type XXI represented a complete rethinking of submarine ergonomics. Earlier boats had been designed primarily for surface operations, with their limited underwater capability almost an afterthought, a parlor trick, to be performed when circumstances demanded it. The Type XXI, by contrast, was designed from the ground up as a submarine first. This meant that spaces were organized around the assumption that men would spend extended periods underwater, living in conditions of extreme confinement and dealing with air quality that degraded steadily as hours passed without surfacing. The layout included improved galley facilities, better ventilation systems, and crew quarters that, while still cramped by any modern standard, represented a considerable improvement over the claustrophobic coffins of earlier designs. The storage of food, fuel, and supplies was positioned with scientific precision. Every cubic meter of space had to serve multiple purposes. A locker that held spare torpedoes might also function as a structural support, while a fuel tank that occupied what might have otherwise been unused space contributed to the boat's weight and trim. The designers were orchestrating a mechanical symphony where every note had to be exactly in its place, where removing even the smallest component might throw the entire system out of balance. It is rather extraordinary to contemplate the number of variables that had to be juggled simultaneously: displacement, stability, range, speed, crew comfort, armament capacity, and that eternal constraint, the structural integrity of the pressure hull against the infinite weight of the sea. The propulsion system's revolutionary character extended beyond the snorkel to encompass a new diesel engine design that was more compact and more efficient than anything that had come before. The engineers had managed to fit greater power into a smaller, lighter package through careful redesign of the combustion chambers, the intake and exhaust systems, and the overall architecture of the engines themselves. This efficiency translated directly into longer range and greater underwater endurance, those precious commodities that every submarine commander craved. Imagine the strategic implications. A boat that could stay submerged longer would be harder to find, would have more time to hunt, would be more likely to slip through the Allied interdiction net and reach its operational areas. The battery system also underwent significant revision, though the fundamental limitation remained. Batteries stored energy but could not generate it on their own, and they could not be recharged while the boat was submerged, except through the diesel engines via the snorkel. The Type XXI incorporated the latest battery technology available to German science, with improved plates and electrolyte chemistry that promised better performance and a longer service life. Yet even with these improvements, the battery remained a constraint, a fundamental aspect of submarine design that would not truly be solved until the advent of nuclear power, which lay beyond the immediate horizon of World War II development. The overall displacement of the Type XXI was approximately 2,000 tons when submerged, which made it significantly larger than the earlier Type XXI boats that had formed the backbone of the German U-boat fleet. This greater size conferred several advantages. More tonnage for fuel meant greater range, more space for crew meant better living conditions and reduced fatigue. More volume for armament meant a more formidable striking capacity. Yet size also brought disadvantages. A larger boat was potentially slower, potentially less maneuverable, potentially more vulnerable to detection due to the larger acoustic signature its engines produced. The design team had to find a careful balance, and whether they had found exactly the right point remained, even to the engineers themselves, something of an open question, a matter that could only be truly answered through actual combat operations, which would come far too late to matter. The designers of the Type 21 understood something that many naval planners of the time had only begun to grasp, that the submarine had transformed from a surface vessel that occasionally submerged into a true creature of the deep, one that would need to be reimagined entirely to survive in waters increasingly thick with radar, sonar, and the coordinated fury of Allied convoy escorts. This realization came almost too late, but when it came, it manifested in a kind of engineering obsession that would consume countless hours of German design teams in the final years of the war. The revolutionary feature that set the Type 21 apart was not, perhaps, a single innovation, but rather the cumulative effect of dozens of carefully integrated improvements working in concert. One of the most significant of these was the introduction of the schnorchel, or schnorchel as the Germans called it, a device that allowed diesel engines to draw in fresh air from the surface while the submarine remained submerged. This might sound like a modest refinement, yet it was transformative. Previous U-boats had to surface regularly to run their diesel engines, which meant periodic vulnerability to detection. The schnorchel eliminated much of that necessity, allowing the vessel to charge its batteries while remaining beneath the waves, becoming less of a surface raider and more of a true underwater predator. The Type XXI also benefited from hydrodynamic improvements that earlier submarines simply could not have achieved. The hull shape itself was refined through countless tank tests and theoretical calculations, reducing drag and allowing for faster underwater speeds. Can you imagine the frustration of designers who had spent years building U-boats that moved sluggishly beneath the surface, watching them desperately try to outrun destroyers, only to glimpse designs that would have changed everything had they arrived just a few years sooner? The new hull form was sleeker, more sophisticated in its proportions, almost organic in its evolution from the blunt, compromised designs of earlier boats. The internal arrangement of the Type 21 represented a thoughtful reorganization of space and function. The control room was shifted to a new position that gave better visibility through the periscope arrangement and improved the coordination of the crew. The torpedo tubes were reconfigured to allow for faster reloading mechanisms. Crew members could now prepare and launch follow-up shots more rapidly, a crucial advantage in the claustrophobic violence of an underwater engagement. The bunks for the sailors, those cramped and uncomfortable berths in which men had spent weeks at a time, were rearranged to maximize livability, a small mercy in vessels that were still fundamentally uncomfortable places in which to exist. But perhaps most crucially, the Type 21 introduced what many historians view as the first truly modern submarine battery system. The batteries that powered underwater movement had always been a constraint, a limitation that forced designers to choose between speed and endurance, between silent running and rapid transit. The new batteries installed in the Type XXI offered significantly greater capacity and efficiency, allowing for longer periods of underwater operation at useful speeds. This was not an invention that captured headlines, yet it represented an almost philosophical shift in how submarines could function. A submarine could now remain submerged for extended periods while maintaining a decent velocity, a capability that would have multiplied the threat they posed to Allied shipping immeasurably. The forward torpedo compartment, that critical space where the weapons waited in their tubes, was redesigned to accommodate not just the standard array of weapons, but also the new acoustic homing torpedoes that German engineers had developed. These Zaunkönig torpedoes, the name meant wren, a small but formidable bird, were revolutionary in their own way, equipped with crude acoustic guidance systems that would turn toward the sound of a ship's propeller. Imagine the psychological impact on an Allied escort commander of knowing that your engines, the very thing that drove your vessel and allowed you to hunt the hunter, had become a beacon drawing your enemy toward you. The diesel-electric propulsion system itself was upgraded, with newer, more efficient engines that produced better output while consuming less fuel. This extended the operational range of the Type 21, allowing it to transit from its German bases to Atlantic hunting grounds and remain on station for meaningful periods before the long journey home. The range was still limited compared to surface ships, yet it was improved enough to matter, to make the difference between a theoretical threat and a practical one. The auxiliary machinery, all the pumps and valves and systems that kept a submarine functioning in the hostile environment of the deep, was modernized and made more reliable. This meant fewer breakdowns during critical moments, fewer situations where a mechanical failure at depth could lead to disaster. Engineering reliability is not the most romantic aspect of military history, yet it is often the difference between success and failure. A boat that works consistently, that does not require constant repair and maintenance, is a boat that can actually be deployed and used. There was also significant attention paid to the electrical systems, the maze of circuits and switches and control panels that had become increasingly complex as submarines incorporated more sophisticated equipment. The Type 21 featured improved electrical distribution systems, better insulation, more reliable fuses and breakers. To anyone outside the naval engineering world, this seems tedious, perhaps even boring. Yet for the men who would operate the vessel, these improvements meant fewer electrical fires, fewer shocks, fewer situations where a catastrophic failure in the electrical system could flood compartments or disable the boat. The acoustic signature of the Type 21 was, by design, quieter than its predecessors. The machinery was mounted on resilient materials that absorbed vibration rather than transmitting it directly through the hull into the surrounding water, where it could be detected by the sensitive hydrophones of Allied listening equipment. The propeller design itself was refined to produce less cavitation, that is, fewer of the telltale bubbles that form when a propeller spins too quickly in water and that emit a distinctive sound recognizable to trained sonar operators. These acoustic improvements were subtle, not easily quantifiable in simple numbers, yet they represented a genuine effort to make the Type 21 stealthier, harder to detect, more likely to approach its target unobserved and unannounced. The true measure of the Type 21's revolutionary nature became clearer as German engineers pushed deeper into the practical engineering required to actually build these vessels at scale. You see, the drawings and the theory were one thing, exquisite blueprints rendered in meticulous detail by brilliant minds in darkened rooms. But translating those blueprints into steel, into working machinery, into something that could actually descend beneath the waves and survive the crushing pressures of the deep, that demanded an entirely different kind of genius. And it was here, in the factories and shipyards scattered across occupied Europe, that ambition began its slow collision with reality. The Type 21 was conceived as a radically different animal from its predecessors, where earlier U-boats had been fundamentally surface vessels that could submerge only briefly and clumsily. The 21 was designed to live beneath the water. Its hull form was optimized for underwater performance rather than surface speed. The streamlined profile, the reduced tower height, even the way its bow swept back, every curve and angle had been reconsidered through the lens of hydrodynamics. But this meant building a submarine that was almost unrecognizably different from anything the German shipyards had yet produced. Consider the challenge facing the engineers at firms like Blohm & Voss in Hamburg or the Deutsche Werft yards in Kiel. They had spent years perfecting the construction techniques for Type XXI U-boats. Their workers knew those hulls in their sleep. The rhythm of riveting, the sequence of assembly, the particular tolerances that had to be maintained, all of this knowledge could be applied almost automatically, almost in a kind of industrial trance. But now they were being asked to begin entirely from scratch. the barrel-shaped hull had to be redesigned. The ballast tank arrangements were completely different. The pressure hull itself required new metallurgy, new welding techniques, new approaches to watertight compartmentalization. And there was a decision made, a fateful choice really, that seemed promising at the time, but would have profound consequences. Rather than building these submarines in one or two carefully controlled facilities where all the precision work could be overseen by a core group of master craftsmen, the German High Command made the determination that the Type 21 would be constructed using a distributed, modular system. The vessel would be broken down into multiple sections: the bow compartment, the mid-body section with its machinery, the stern section, each of which would be built in different yards, sometimes in different cities, sometimes even different countries. These modules would then be transported by rail or barge to a central assembly yard where they would be joined together. On the surface, this was a sensible approach to wartime production. If Germany's ports and shipyards could be bombed, and indeed, by this stage of the war, they were being bombed with alarming frequency, then perhaps distributing the construction work across multiple facilities would provide a measure of redundancy. If one yard was destroyed, the others could continue. The modules could be hidden in forests or warehouses, dispersed in ways that a completed submarine could never be. It seemed, in the abstract planning rooms, like an elegant solution to a modern industrial problem. But modular construction demands precision of a different order entirely. When you are assembling sections built separately, the tolerances become critical. A hull section built in one city had to mate perfectly with a section built in another city, sometimes months earlier, by workers who had never communicated directly. The diameter of a tunnel had to be exact. The thickness of a weld had to be within fractions of a millimeter. Imagine trying to join two cylinders of steel, each perhaps 40 feet long, when they've been built in isolation, transported across hundreds of miles of wartime Europe, and you need them to form a pressure hull that will be subjected to the weight of the ocean itself. It's a problem that demands the most careful quality control, the most rigorous inspection, the most meticulous attention to detail. The German Naval Administration created a special organization to oversee this distributed construction effort. They called it the Elektroboots program, investing enormous resources in planning, in inspection protocols, in the coordination that such an undertaking would require. But they were working within a constraint that became increasingly severe as the war progressed: time. There was always the sense that if the Type 21 could be produced in sufficient numbers quickly enough, if those larger, faster, more capable submarines could be deployed in the Atlantic in waves, then perhaps the tide of the war could turn. Perhaps the staggering losses that the U-boat fleet had been suffering could be reversed. Perhaps superiority could be regained. By late 1943 and into 1944, as the Type 21 program accelerated, the shipyards and component factories were working at an almost delirious pace. The program began to consume resources, labor, materials, and attention at a scale that became almost mythical in its ambition. And yet, think about what else was happening in Europe at this moment. The German war economy was fragmenting under the stress of fighting on multiple fronts. Raw materials were growing scarcer, skilled workers were being drafted into the military. Bombing campaigns were becoming more devastating and more frequent, and the political will to sustain such an enormous submarine construction effort in the face of mounting problems at every other level of warfare, that too was being tested in ways that nobody had quite anticipated. So the modular construction proceeded, this vast, intricate ballet of movement and assembly, factory work and transportation, inspection and correction. But beneath the surface of all this organized effort, there were signs, small at first, then increasingly difficult to ignore, that perhaps the system itself might not be equal to the challenge it had been given. The submarines being assembled from these scattered modules were beginning to show problems. Some of the joins didn't fit quite as perfectly as they needed to. Some of the electrical systems, integrated into hull sections built in different places, didn't communicate with each other as smoothly as planned. Some of the vessels, when finally put in the water for testing, displayed unexpected behaviors, quirks, and instabilities that suggested something fundamental might be slightly wrong, but solving that wrong, when it stemmed from the mismatch of precisely constructed pieces, was far more difficult than any single engineering challenge had been. The question that haunted German naval command through the middle months of 1944 was deceptively simple. How many of these new Type 21 boats could actually be built, and how quickly could they reach operational status once they were? The answer, as it turned out, would prove far more complicated than the optimistic projections that had emerged from the drawing boards and conference tables in Berlin. By late 1943 and into the opening of 1944, the construction program had begun in earnest. The Blohm and Voss yards in Hamburg, the Deutsche Werke in Kiel, and the Howaldswerke in both Kiel and Hamburg were all receiving their orders, their blueprints, their quotas of materials and labor. But the German industrial machine, for all its formidable engineering prowess, was no longer operating at full efficiency. The Allied bombing campaign had intensified dramatically. The daylight raids over German cities and industrial centers had become relentless, systematic, designed not merely to disrupt production, but to demoralize, to fragment, to stretch already thin resources even thinner. Consider the challenge faced by the shipyards themselves. The Type 21 was not simply a faster U-boat, it represented a wholesale reimagining of submarine architecture, which meant that every component, every system, every integrated element had to be manufactured to unprecedented precision. The high-pressure hull required metallurgy that was both strong and flexible, capable of withstanding depths and pressures that would have crushed earlier vessels. The batteries alone, those massive accumulators that would power the boat underwater, were so large, so heavy, that they had to be integrated into the very fabric of the submarine's structure during construction. You couldn't simply bolt them on afterward. You couldn't improvise. Every step had to follow in sequence. And yet the bombing campaign continued. In July 1944, the Blohm and Voss yard suffered catastrophic damage from a concentrated raid. The destruction was so severe that it set back the entire program by months. Some historians argue by as much as 6 months or more. Workers who had been trained to assemble these intricate machines had to be reassigned, relocated, or in some cases, they simply disappeared into the chaos of collapsing German logistics. Raw materials that had been earmarked for the Type 21 were diverted to repair bomb damage, to rebuild facilities, to meet competing demands from the Luftwaffe, from the Wehrmacht, from the desperate and multiplying crises on every front. There was also another, more subtle problem that began to emerge as the first few Type 21 hulls were laid down. The design, for all its brilliance, was remarkably complex. It demanded a level of standardization in parts, a level of quality control in manufacturing, that German industry, fragmented as it was by war, by bombing, by the demands of multiple competing priorities, could not consistently deliver. Some boats that came off the slips were mechanically sound. Others had defects in welds, in electrical systems, in the integration of components that wouldn't become apparent until the vessels were already at sea, already committed to combat, already beyond the point where repairs were simple. The German Navy, moreover, was deeply aware of these problems. Admiral Karl Dönitz, the commander of the Kriegsmarine submarine force, and soon to be supreme commander of the entire Navy, understood with crystalline clarity that time was the one resource Germany could no longer afford to waste. Every month that passed saw the Allies growing stronger. Every month saw American production accelerating, British capabilities expanding, Soviet forces grinding relentlessly westward. The Type 21 was meant to be Germany's answer to this catastrophic imbalance, its potential trump card, in a game where Germany was steadily losing all the other hands. So there emerged, in the middle of 1944, a peculiar kind of desperation within the German naval establishment. Not panic exactly, but a kind of urgent, focused anxiety that manifested in constantly revised timelines, in increasingly aggressive production targets, in the insistence that the yards work at maximum capacity despite the deteriorating conditions in which they operated. Dönitz himself took a personal interest in the Type 21 program. He visited the yards, he reviewed progress reports, he pushed his subordinates to accelerate delivery schedules. The first Type 21 to be completed was U-250-1, which rolled out of the Blohm and Voss yard in June of 1944. It had taken an enormous commitment of resources, of skilled labor, of carefully allocated materials. The Germans celebrated it quietly, because by mid-1944, they had learned not to broadcast their weapons programs too loudly, not to invite more attention from Allied intelligence services. But internally, there was a sense of vindication. The boat existed. It was real. It was a physical manifestation of the vision that had animated the design bureaus for years. Yet U-251 would not enter service, would not sail on its first operational patrol until October of 1944. 4 months. 4 months between a boat's completion and its actual deployment. These months were consumed by trials, by sea tests, by the endless process of working out the inevitable problems that arose when a revolutionary design was put into the water for the first time. The crews had to be trained, the boat's systems had to be calibrated and recalibrated. Some elements of the design, when tested in the actual environment of the sea, behaved differently than they had in the calm waters of the testing tanks and the theoretical calculations of the engineers. And as U-250-1 was being readied for service, as it was consuming the attention and resources of the German Navy, other Type 21 boats were still being constructed. By the summer of 1944, there were dozens of hulls at various stages of completion across the German shipyards. On paper, the estimates suggested that by the end of 1944, there might be as many as 30 or 40 Type 21 boats ready for operations. By the end of 1945, the projections climbed to hundreds. The idea, the genuine hope that animated German strategic planning in these months, was that even if only a fraction of these boats could be deployed, they would be enough to turn the tide in the Atlantic, to disrupt Allied convoy routes, to inflict such losses on merchant shipping that Britain would be strangled into submission, or at the very least, negotiation. But there was something almost dreamlike about these projections, something that historians now recognize as a kind of willful blindness to the reality of the situation Germany faced. How many of these boats could truly be completed before Germany's total collapse? How many could be crewed? How long would the yards continue to function under increasingly devastating bombing campaigns? These were the questions that the more realistic planners within the German Navy were beginning to ask themselves, even as the official rhetoric continued to emphasize the transformative potential of the new submarine fleet. The Type XXI existed, then, in a peculiar limbo between ambition and reality. Germany's naval command had become increasingly aware, by late 1943, that the conventional U-boat, the Type Vehic that had dominated the Atlantic, was no longer sufficient. The escort vessels had grown too numerous, their detection equipment too sophisticated, their tactics too refined. The wolf packs that had once terrorized shipping lanes were being hunted with an efficiency that only months before would have seemed impossible. And so the pressure mounted, not just from the enemy, but from within the Reich itself, from engineers and admirals who understood that without a radical departure, the submarine arm would become nothing more than a casualty factory, sending men down in vessels that could no longer hope to survive. It was this desperation, perhaps, that gave birth to genuine innovation. The Type 21 was not merely an improvement, it represented a leap forward so significant that some historians consider it the first true modern submarine. Its hull form departed from the traditions that had governed U-boat design for decades. Where earlier submarines had been built as surface vessels that could submerge, the Type 21 was conceived as a craft, optimized first and foremost for underwater operation. The streamlined hull, the elimination of the prominent conning tower that had characterized its predecessors, the overall reduction in drag, these were not luxury refinements. They were born from a single, driving principle: underwater speed and silence. The engineers understood something fundamental. that would not be fully appreciated until after the war's end. They grasped that the future of submarine warfare lay not in the surface attack, not in the brief moment when a U-boat might rise to loose a torpedo at a merchant vessel outlined against a darkening sky. The future lay beneath, in sustained underwater endurance, in the ability to move through the depths undetected, to maintain velocity while submerged, to become, in essence, a creature of the ocean rather than a refugee from it. Consider, if you will, the power plant that gave the Type XXI its extraordinary capability. The boat was equipped with a hydrogen peroxide turbine engine, the Walter turbine as it was known, named after its designer Helmuth Walter. This engine operated on a principle that seems almost fantastical in its simplicity. Hydrogen peroxide, when properly catalyzed, breaks down into steam and oxygen, providing propulsion that required no air intake, no surface ventilation, no betrayal of the submarine's position through the telltale diesel exhaust that had always marked the location of submerged U-boats. A Type XXI, using its Walter turbine, could remain completely submerged while traveling at speeds of 17 knots or more, faster than most escort vessels of the time could manage on the surface. The implications were staggering. A hunting submarine that moved faster than its hunters while remaining invisible. It seemed, on the drawing board at least, like a technology that might genuinely alter the course of the naval war. But engineering promise and wartime production were two entirely different matters. The Type XXI program encountered difficulty after difficulty as the war ground on. The hydrogen peroxide engine itself was temperamental and unstable in the hands of less experienced technicians. The fuel was corrosive, demanding specialized storage and handling. There were accidents during testing, failures that killed experienced submariners and set the program back by weeks or months. The sheer complexity of the boat's systems meant that construction took longer than anticipated. Germany's already stretched industrial capacity under increasing aerial bombardment could not keep pace with the demanding specifications. By the time a Type XXI was ready for operational deployment, the Atlantic itself had become a far more dangerous place than it had been even 2 years prior. The window of opportunity that the boat was designed to exploit was rapidly closing. There was, as well, the matter of what we might call institutional resistance. Not deliberate sabotage, but rather the simple fact that the German submarine force had developed over nearly a decade around the older types. The officers who commanded, the mechanics who maintained, the young men who crewed these vessels, they understood the Type XXI intimately. They had learned its quirks and capabilities through years of experience. The Type XXI represented an unknown, a departure from everything they had trained to master. There would be a learning curve, and in wartime, learning curves cost lives. Some commanders, understandably, were hesitant about transitioning to new technology when they had honed their skills with proven, if aging, designs. The first Type XXI to become operationally ready was designated U-2501. She was completed in June of 1944, months behind the originally optimistic schedule. Her first commander was a relatively young but experienced officer named Adalbert Schnee, who had previously commanded a Type Viek with considerable success. Schnee received his new vessel with a mixture of enthusiasm and trepidation. He understood its theoretical capabilities, but the boat was still in many ways an unknown quantity, still undergoing trials and modifications, even as it was being prepared for its first patrol. How does one command a vessel that is, in a sense, still being invented? How does one trust systems and tactics that have never been tested under the pressure of actual combat against a skilled and determined opponent? The trials and preliminary operations of the early Type XXI boats revealed both the promise and the perils of the new design. In tests, the submarines demonstrated underwater speeds that were genuinely remarkable. Submariners who had spent years in conventional boats found themselves astounded by the acceleration, the responsiveness, the sheer underwater performance of the Type XXI. And yet, there remained persistent mechanical issues, reliability concerns that could not be dismissed as mere teething troubles. A submarine that fails in combat is not a marvel of engineering, it is a tomb. The pressure, always present in submarine operations, intensified as these new vessels prepared for their first combat patrols. There was, in the minds of those responsible, a nagging uncertainty. Had they created something that would transform the naval war, or had they invested enormous resources in a project that would prove, when tested in earnest, to be another of those brilliant visions that could not survive contact with reality? The Type XXI had arrived at a moment when the Atlantic had already turned against Germany. The wolf packs that once terrorized convoys in loose, coordinated formations were now hunted relentlessly by Allied escort vessels, equipped with new radar systems and depth charges of devastating precision. The tide of the war had shifted so thoroughly that even the most optimistic German admiral understood that any technological leap would need to be extraordinary, almost supernatural in its capabilities, to reverse what had already been decided in terms of logistics, production, and sheer industrial will. And yet the X-Pens promised something that submarines of previous generations could never quite achieve: the ability to hunt beneath the waves rather than upon them, to spend entire voyages submerged, breathing through a technological device that made the surface world seem almost unnecessary. The schnorchel apparatus that German engineers had perfected, borrowed initially from the Dutch and refined through years of trial and error, represented the closest thing to liberation the submarine arm had experienced in years. Picture, if you will, a simple idea made elegant through necessity, a tube that could extend above the water while the boat remained almost entirely submerged, drawing in fresh air for the diesel engines while allowing the captain to maintain depth, to see through the periscope, to think in the shadows. Earlier attempts at similar devices had been temperamental and dangerous, prone to snapping off in rough seas or allowing water to flood the engine room when a wave swept over them unexpectedly. But by the time the Type XXI entered service, the schnorchel had been refined to a degree that made sustained underwater cruising not merely possible, but genuinely sustainable for hours at a time. This fundamentally changed the nature of submarine warfare in ways that strategists were only beginning to grasp. A submarine that could remain submerged meant it could no longer be spotted by aircraft from above, that sprawling search zone that the Allies had worked so tirelessly to establish over the Atlantic. It meant that the elaborate systems of convoys and their escort patterns, refined over years of bitter experience, might need to be reconsidered entirely. The acoustic advantage shifted as well. Traditional U-boats, forced to surface regularly to recharge their batteries or to simply breathe, created a detectable signature in multiple ways: visually, through the periscope watch, through the sounds of their conning towers breaking the surface. The Type XXI, gliding through the depths while drawing breath through its schnorchel, announced itself only to the most sensitive listening equipment, and even then, only if someone was listening in exactly the right place, at exactly the right moment. But the schnorchel, for all its promise, was not the 21's only revolutionary feature. Consider the basic hydrodynamics of the boat itself. Previous U-boats had been designed according to principles that traced back to the earliest submarines: sleek above water, functional below, a compromise between the two environments that had never felt entirely satisfactory for either one. The Type XXI broke from that tradition. Its designers had asked themselves a question that seemed almost obvious in retrospect. What if we designed this boat, assuming it would spend 95% of its time beneath the surface? What shape would we give it then? The answer was a hull form that sacrificed the modest seaworthiness of surface cruising in exchange for dramatically improved underwater efficiency. The X-Plane Stid was faster submerged than many of its predecessors were on the surface. This alone was revolutionary, and it could turn with an agility that earlier boats simply could not match. Its diving time, the interval between the order to submerge and the moment when the boat reached periscope depth, had been cut to mere minutes. In earlier U-boats, this process took 5 or more minutes of vulnerability. The battery capacity had been nearly doubled, and while this meant that the boat was heavier, less buoyant, requiring more careful calculation of ballast, it also meant that a submerged Type 21 could travel at moderate speed for genuinely extended periods. The calculations that submarine skippers had to perform, the careful arithmetic of power consumption and remaining charge that had haunted them on every patrol, could be marginally less frantic. This was not a luxury, it was a fundamental shift in tactical possibility. The question that began to occupy the minds of Allied planners, particularly after a handful of Type XXIs entered active service in early 1945, was whether existing anti-submarine tactics remained adequate. The convoy system itself, that elaborate dance of merchant ships and their protectors, had been developed in response to specific U-boat capabilities. If those capabilities had fundamentally changed, had not the entire defensive system become obsolete? The answer, it would turn out, was more complex than the question itself, for the Type 21 faced obstacles that no amount of innovative engineering could entirely overcome. But in those first months, when the German Navy itself was struggling to commission these boats, to crew them, to get them into position to do any damage at all, the theoretical threat posed by a submarine with these capabilities was enough to cause genuine concern among the planners of the Western Allies. The German Navy understood, better perhaps than the Allies did, that quantity mattered less and less as the war continued. The Nazis had lost the ability to project force across the Atlantic in traditional ways. The surface fleet had been methodically hunted and destroyed or neutralized. The Luftwaffe, never truly effective against submerged targets, was now barely capable of defending German airspace itself. What remained, what could possibly still threaten the flow of supplies to Britain and the staging areas for the invasion of Europe, was the submarine. And if the submarine arm could not defeat the Allies through numbers, and it was becoming clear that it could not, then it would have to defeat them through innovation. The Type 21 was that innovation, or at least it was meant to be. Whether it would have made a meaningful difference, whether the timing was right, whether production could have reached the scales that would have been necessary, these are questions that historians have debated without ever quite reaching certainty. What is certain is this: the Type 21 represented the furthest that German submarine design advanced before the war ended. It embodied principles that would, in modified form, carry forward into the post-war era. The Soviet Union, when it studied the captured examples of these boats and the technical documentation that survived the fall of Germany, saw in them the blueprint for its own submarine programs. The Western Allies, too, absorbed the lessons that the 21 represented. The boat that was meant to win the Battle of the Atlantic, or at least to restore some semblance of parity to that grinding campaign, instead became a monument to what might have been, had the circumstances of history aligned differently, had German industry been more resilient, had the priorities of the Nazi regime been ordered according to pure military logic, rather than the erratic impulses of its leadership. As 1945 wore on, the Type XXIs that had actually entered operational service undertook patrols that bore little resemblance to the triumphant hunts of earlier years. They were rare enough to be treated as objects of considerable value and considerable caution. Every boat that was commissioned represented not just the product of intensive labor by German workers and engineers, but also the consumption of resources that were becoming ever more scarce, ever more desperately needed elsewhere. The crew members who volunteered or were assigned to these boats understood, with the clarity that comes from living in a society in the grip of impending collapse, that their chances of surviving the war in their new submarine were probably not substantially better than if they had remained in the conventional U-boats. The technological miracle, if it could even be called that, had arrived too late to perform the miracle that it had been designed to achieve. In the final months of 1944, as the Type 21 remained locked in its design and construction phase, the German Naval High Command faced a reality that grew harder to deny with each passing week. The war at sea had transformed entirely. What had once been the hunting grounds of the Kriegsmarine, the vast Atlantic, the convoy routes where merchant ships gathered like vulnerable schools of fish, had become instead a gauntlet of enemy patrols, aircraft, and destroyers that seemed to multiply rather than diminish. The Type XXI was meant to reverse this, but the question that haunted the admirals was whether it could arrive in time to matter at all. The boat's revolutionary design meant that construction couldn't follow the familiar patterns that German yards had perfected over years. The prefabrication method demanded new tooling, new assembly lines, coordination between multiple shipyards that had never worked in concert before. Blohm und Voss in Hamburg would build the forward sections. Deutsche Werke in Kiel would handle the middle. Holzwerke in Hamburg took on the aft compartments. And then there were the subcontractors, firms scattered across the Reich, each responsible for some critical component. What should have been an elegant solution to speed production instead became a logistical puzzle that grew more complex each day. By late 1944, the first Type XXI boats under construction were still months, perhaps many months, away from launching. The Allies could see this was happening. Intelligence reports filtered back through Swedish contacts, through Portuguese middlemen, through the usual murky channels of wartime espionage. The British and Americans knew something new was coming. They didn't yet grasp its full capabilities, but they understood enough to be concerned. What should be done about it? That question began to occupy the strategic thinking of naval planners in both London and Washington. Meanwhile, the older boats continued their operations, growing fewer as losses mounted. The Wolfpack concept, which had once seemed to promise such devastating results, was now merely a ghost of its former self. The U-boats still put to sea, yes, they had to, but they did so knowing that the odds had shifted fundamentally. A boat that might have returned safely from a patrol 2 years earlier would now likely end up on the bottom of the Atlantic, victim of an escort carrier or a well-placed depth charge. The crews knew it, the commanders knew it, and the German admirals knew it most of all, which made the promise of the Type XXI seem almost desperately precious. Dönitz himself had become an advocate for revolutionary change, having seen what conventional tactics could no longer accomplish. He pressed for acceleration of the Type XXI program, with an intensity that sometimes bordered on obsession. He understood submarine warfare at a level few men ever could. He had lived it, commanded boats himself, understood the psychology of men trapped in steel cylinders hunting in the depths. But he also understood mathematics and probability, and those told him that without fundamental technological advantage, the submarine arm of the Kriegsmarine was entering a twilight from which it would never emerge. The pressure to accelerate production was immense, but it collided constantly with physical reality. Workers were exhausted. Many were conscripted foreign laborers working under conditions that ranged from merely harsh to genuinely brutal. Materials that had once been readily available now had to be fought for. Aluminum, which the Type XXI required in substantial quantities, was increasingly scarce as the Luftwaffe demanded more of it for fighter production. Steel that had been allocated to the yards was rerouted to tank factories or gun manufacturers. The Reich was engaged in a desperate struggle on multiple fronts, and resources flowed toward the battles that seemed most immediately threatening. There were also the Allied bombing campaigns to contend with. The bombing of German cities and industrial centers had intensified throughout 1944. Hamburg, where Blohm und Voss maintained its facilities, had already been devastated in earlier raids. Kiel, the naval center, faced frequent attacks. The yards themselves were hardened targets, heavily defended, camouflaged, dispersed where possible, but damage occurred nonetheless. A single well-placed bomb could halt production for weeks or even months. And then there was the psychological toll. Workers wondered, quite reasonably, whether they would see their families again. Some sought safer work or found ways to disappear. Absenteeism climbed. Yet boats were being built. By December 1944, the first Type XXI U-2501 was nearing completion. Its pressure hull had been finished. The diesel engines had been installed. Testing was beginning, though it had to be done carefully and in sections, since the revolutionary design meant that conventional acceptance procedures didn't quite apply. The Kriegsmarine's technical inspectors found themselves in unfamiliar territory, evaluating systems and capabilities for which there were no established standards. Could they trust the engineering calculations? Would the hull really hold at the depths the designers claimed? The only way to find out was to build the boats and try them. The waiting grew almost unbearable. Germany's leadership understood, at some level, that the war could no longer be won through conventional means. The idea of a wonder weapon, a revolutionary technology that might shift the balance, had become almost a sort of collective hope, though most thinking men knew hope alone wouldn't suffice. But the Type 21 represented something tangible, something real. It was being built. It existed in steel and components and skilled labor. For Dönitz and his inner circle, it represented one final throw of the dice, one last chance to demonstrate that innovation and German engineering could overcome the material disadvantage that was slowly crushing the Reich. What sustained these men through this period, one might wonder, was partly faith in the boat itself, but partly something deeper, a kind of commitment to see the task through regardless of likelihood. They had already invested so much. The design work, the planning, the beginning of production, it had all consumed enormous effort and resources. To stop now would feel like surrender, even if surrender itself was beginning to feel inevitable to clearer minds. And so the work continued, day after day, in the shipyards and factories scattered across a Germany that was slowly but inexorably contracting under the weight of total war arrayed against it. The crews who would eventually man these new boats were being trained in secret facilities. They were learning to operate systems that didn't yet fully exist, training for capabilities they'd never seen demonstrated, preparing for tactics that existed mostly in the theoretical mind of naval planners. This created a strange sort of anticipation, a knowing that something extraordinary was being prepared, even as the present grew daily more desperate. Would the Type 21 arrive in time? Would there be enough boats? Would they actually perform as designed? These questions hung in the air like a constant, unanswered refrain. In those final months of the war, as the Type 21 submarines began their operational trials in the Baltic waters, a profound and almost haunting paradox was taking shape across the German military apparatus. The men who had engineered this revolutionary vessel, the designers, the metallurgists, the engineers who had pored over calculations in dimly lit shipyards, were beginning to understand with painful clarity that they had created something of extraordinary capability in a nation that no longer possessed the infrastructure, the resources, or perhaps most crucially, the time to deploy it effectively. The war that had once seemed to stretch endlessly toward German victory was now collapsing inward with a momentum that no submarine, however advanced, could reverse. Consider the sheer scale of what needed to happen for the Type 21 to make any material difference to the outcome of the Atlantic struggle. The boats were rolling out of the construction yards at Blohm & Voss and other facilities, each one a testament to engineering brilliance, yet each one also represented a finite quantity of steel, of diesel oil, of skilled labor, in a nation that was hemorrhaging all three at an accelerating rate. By early 1945, Germany was burning through resources at a rate that contemporary military analysts struggled to comprehend. The strategic bombing campaigns had rendered entire industrial regions ineffective. The Luftwaffe, starved of fuel, was barely operational. The Wehrmacht was locked in a grinding retreat on two fronts, consuming ammunition and men in quantities that could not be replaced. In this context, asking how many Type 21 submarines could genuinely be brought to combat readiness became almost a question of mathematics rather than hope. The trials that took place through the winter and into the spring of 1945 revealed something striking. When the Type 21 was handled by skilled crews who had undergone the proper training protocols, and here we must note that such crews were increasingly rare as experienced submariners were either lost in earlier engagements or scattered across the German naval system, the boat performed almost exactly as the designers had predicted. The diving characteristics were stable, the underwater acceleration was remarkable, the schnorchel apparatus functioned with greater efficiency than anything the Kriegsmarine had previously fielded. Crews reported a sense of capability that stood in sharp contrast to the vulnerability they had come to associate with earlier U-boat classes. Yet between prediction and combat deployment lay a chasm of logistical and organizational challenge that no amount of technical excellence could bridge alone. The question that haunted both the Naval High Command and the engineers was deceptively simple. How long would it take to raise operational readiness to a point where Type 21 submarines could begin hunting in meaningful numbers? The answer that emerged from various assessments was deeply troubling. Estimates ranged from several months to nearly a year, depending on which aspect of the problem one examined. Crew training alone represented an enormous undertaking. Each Type 21 carried experienced men in key positions, but the rest of the crew needed to understand a vessel whose capabilities and whose operational procedures differed fundamentally from earlier boats. The diesel-electric propulsion system, while proven, required a different approach to energy management and tactical deployment. The schnorchel apparatus, which allowed the submarine to run its diesel engines while submerged, was itself a technology that demanded careful handling and continuous vigilance. It was not enough to simply hand a man a manual and declare him competent. It required time, repetition, and ideally, experienced instructors who themselves understood the new vessel intimately. This training pipeline was itself under extraordinary strain. The Baltic Sea, which had been selected as the primary venue for Type 21 trials and training, was becoming an increasingly dangerous place for German naval operations. The Soviet Navy, reinvigorated and growing in capacity with every passing week, was expanding its presence in these waters. Defensive operations consumed resources and attention that might otherwise have been devoted to training and familiarization. It created a situation where the boats designed to revolutionize submarine warfare were themselves vulnerable to attack during the very exercises intended to make them combat-ready. The bitter irony would have been humorous if the stakes had not been so desperately high. Here were the most advanced submarines in the world, being stalked and harried by an opponent with inferior technology but superior numbers and positioning in waters that had become as dangerous as any active combat zone. The supply situation, meanwhile, continued its downward spiral. Diesel oil, which had been a chronic shortage throughout the later war years, was now present in quantities that forced painful decisions about operational tempo. Spare parts for the schnorchel system were backordered. The specialized materials required for the new welding techniques that kept the Type 21's hull integrity superior to its predecessors were subject to competing claims from multiple branches of the military. The very factories that produced these components were themselves under attack or at risk of attack. Supply trains that had once been reliable were now subject to disruption from advancing Allied forces. A submarine sitting in a shipyard waiting for a specific part could wait for weeks, then months. During that time, another boat that might have been completed was instead held up waiting for the completion of the first. The cascading delays were immense and, for all practical purposes, impossible to overcome given the shrinking territory and resources available to Nazi Germany. The engines that powered the Type 21 represented something altogether different from what had come before. Where earlier U-boats had relied on diesel propulsion when surfaced and battery-driven motors when submerged, the engineers overseeing this revolutionary class understood that they needed to fundamentally reimagine how a submarine could operate beneath the waves. The answer lay in the schnorchel technology that had matured considerably by the early 1940s, combined with new diesel engines that could draw air through a tube while the boat remained at periscope depth. But even this was not enough for what the German Navy envisioned. The Type XXI incorporated the Walther turbine engine, an experimental propulsion system that burned hydrogen peroxide in a closed-cycle manner, theoretically allowing the submarine to operate underwater without the constant need to surface or snorkel. This was not a perfect solution, and the technology remained temperamental, prone to explosions if mishandled, but the promise was intoxicating. A true submarine that could remain submerged for extended periods while traveling at speeds that would have been unthinkable just years earlier. Consider for a moment what this meant in the context of the Atlantic crossing. The conventional U-boats that had waged the Battle of the Atlantic could achieve perhaps 17 knots when running on the surface, but underwater, they were sluggish, limited to roughly 8 or 9 knots before their batteries became exhausted. An escort vessel, a destroyer or frigate, could often outrun a diving U-boat, and if the submarine could not maintain speed below the surface, it became vulnerable to the coordinated tactics of convoy defense. The Type 21 changed these equations. With its new diesel engines and careful hydrodynamic design, it could reach 13 knots while submerged on diesel power alone, and potentially over 15 knots if the Walther turbine functioned correctly. This meant that a convoy escort could no longer simply dive and wait out an attack. The submarine could pursue, could maneuver, could engage in a way that turned the underwater warfare paradigm on its head. The hull itself had been refined through countless calculations and model tests in the tank facilities at Wilhelm Freuds Institute in the north of Germany. The engineers had reduced what they called form drag, the resistance created by the shape of the vessel moving through water, to an unprecedented degree. Every protrusion was minimized or eliminated. The periscope standards were recessed. The conning tower was integrated into the hull in a more streamlined fashion. The ballast tanks were positioned with mathematical precision to allow for rapid diving and surfacing. It was as though the designers had stripped away every unnecessary element until what remained was something almost organic in its efficiency. The submarine seemed less like a machine and more like a creature of the deep, shaped by millions of years of evolution rather than drawn by engineers in a war room. The interior arrangement of the Type 21 reflected the lessons learned from countless patrols and dozens of lost U-boats. The crew quarters, while still cramped and cold, were positioned with greater attention to human factors than had been shown in previous designs. Bunks had somewhat more headroom. The galley was placed in a location that made some sense from a workflow perspective. The battery compartments, which occupied a significant portion of the boat's volume, were positioned low and fore and aft to maximize the space available for the crew and the sensitive equipment they would need to operate. Ventilation systems had been improved, though submarine air quality would remain a perpetual challenge. When a U-boat was submerged and forced to remain quiet to avoid detection, the air grew thick and foul, carbon dioxide rising to dangerous levels, while the men inside breathed harder with each passing hour. This was not something that could be entirely solved, but the Type 21 made incremental improvements that would have been welcomed by any man who had endured a deep-diving silent run. What might strike an observer of the technical drawings was the emphasis placed on survivability. The pressure hull, the inner skeleton of the submarine that actually contained the water when diving, was made of a superior grade of steel that could withstand greater depths than anything in the U-boat fleet. This allowed the Type 21 to dive deeper, to perhaps 800 meters or slightly beyond, where many Allied depth charges could not reach. The internal compartmentalization had been carefully considered, so that if one section flooded, the remaining compartments could potentially keep the boat afloat. Hatches between sections were reinforced. Escape trunks, the mechanisms by which a crew might attempt to exit a stricken submarine at depth, were present in greater number than on some earlier designs. Whether these measures would have made a meaningful difference in an actual sinking was debatable, but the intention was clear. The German Navy had learned a bitter lesson about losses at sea, and every refinement to the Type 21 incorporated the accumulated knowledge of 3 years of relentless war. The Type 21 also represented a break from the organizational chaos that had plagued U-boat production in earlier years. By the time the design was finalized in late 1943, the German industrial state had developed something approaching a production system. Smaller yards that had previously built U-boats independently would be given specific components to manufacture. A yard might specialize in pressure hull sections, while another produced the diesel engines, and yet another assembled the electrical systems. These components would then come together at larger assembly points, where the complete boats could be integrated and tested. This was not, it should be said, a perfectly efficient system. German industry was under tremendous strain by this period, facing bombing campaigns that grew ever more devastating, supply shortages that seemed to worsen with each passing month, and labor situations that ranged from difficult to catastrophic. But it was an attempt, at least, to organize production in a rational manner. The first Type 21 to be laid down entered construction in the spring of 1944. Its hull number was U-2501, a designation that would eventually become historically significant, though not in the way that the men who built it might have hoped. The construction proceeded slowly at first, delayed by the very challenges that plagued German industry in this period. Materials were difficult to secure, skilled workers were being drawn away to other essential productions. The bombing raids that struck German cities and facilities with increasing regularity meant that shipyards themselves had to be rebuilt or redirected even as they attempted their work. And there was another problem, perhaps more fundamental than either of these. The Type XXI required components and systems that did not yet fully exist. The Walther turbine engines were experimental. The new sonar systems, the improved radar detection equipment, these were still being refined even as production drawings were being finalized. It becomes clear, when examining the historical record from this period, that the German Navy was attempting something extraordinarily ambitious in a time frame that was growing impossibly short. The Type 21 was not merely an incremental improvement over earlier U-boats, it was a fundamental recasting of what a submarine could be. To accomplish this, to move from design to operational deployment, would have required years of testing and refinement. The Type XXI had perhaps 18 months, perhaps less, before the entire context of the war would shift in ways that no submarine design, however revolutionary, could offset. The crews who trained for these submarines lived in a peculiar state of awareness, knowing they had been assigned to vessels that barely existed, or existed only in fragments scattered across German shipyards in the final winter of the war. There was no time for the usual methodical apprenticeship that submarine service demanded. New officers and enlisted men found themselves absorbing months of theoretical knowledge in weeks, sometimes days, moving through hastily organized schools where instructors themselves were often learning the specifications of the Type 21 as the blueprints came hot from the design offices. The irony was not lost on anyone who understood the sea, that they were being trained for the most advanced submarine ever built, yet trained under conditions of extraordinary haste and improvisation. The psychological weight of this cannot be overstated. Young men in their 20s and 30s, many of them veterans of earlier U-boat campaigns where the casualty rates had become almost incomprehensible, now faced the knowledge that they would be commanding or serving aboard machines unlike anything they had encountered before. The Type XXI's hull was stronger, its diving capabilities sharper, its speed underwater revolutionary, but would these advantages matter if the war was already lost? Some sailors recorded their thoughts in letters home, and those letters reveal a strange mixture of pride in German engineering and a creeping sense of fatigue that ran deeper than mere physical exhaustion. They had learned, through 5 years of war, what it meant to live in metal boxes beneath the ocean, listening for the sounds of approaching hunters, feeling the distant concussions of depth charges through the hull. Could they endure it again, even with better technology? What made the training all the more surreal was that many of these new submarines existed only as rumors and partial completions. The first Type 21 had been launched in April of 1944, but operational readiness remained years away. Crews would be assigned to U-3008, U-3009, U-3010, and others that still had weeks or months of fitting out ahead of them. Some boats existed only as numbered hulls in the slips, their construction halted by bomb damage or material shortages. The men selected for these commands and crew positions understood, on some level, that they might spend weeks in training for a submarine that would never be finished, or would be finished too late to matter. Yet they trained anyway, because that was what soldiers and sailors did. They followed orders. They prepared for a future they could neither predict nor control. The Type 21's revolutionary snorkel system became a centerpiece of crew training. This innovation allowed the submarine to run its diesel engines and recharge its batteries while submerged, at periscope depth, using an intake tube that protruded above the water's surface. In theory, this meant the boat could remain underwater almost indefinitely, limited only by the endurance of its crew and the capacity of its food stores. In practice, the snorkel created new dangers and new requirements for skill. The intake could be damaged by waves, forcing the diesel engines to suck air from inside the submarine and creating a sudden, catastrophic pressure drop that could injure ears and lungs. Crews had to learn to operate the snorkel in rough seas, to recognize the subtle signs that something was wrong, to shut it down instantly if conditions deteriorated. It was a technique that demanded constant attention and a kind of meditative awareness of the submarine's relationship with the ocean around it. One imagines the submarine's training facilities, probably in places like the Baltic, where the water was calmer and easier for novice crews to manage. They would practice submersion, practice emergency blowing of the ballast tanks, practice the coordination between officers in the conning tower and the ratings in the engine room. They would learn the Type 21's unique acoustic properties. The boat was quieter than any predecessor, which meant crews had to adapt to an environment where they heard less of the outside world through the hull. The older U-boats, with their greater structural stress and less sophisticated hulls, had conveyed a constant background of groaning and creaking that experienced sailors had learned to interpret as a kind of language. The Type 21 was, by comparison, eerily silent. Was this an advantage or a psychological burden? Both, perhaps. The quietness suggested safety, yet it also meant less feedback from the ocean itself. The training also included instruction on the Type 21's improved electrical systems and its capacity for higher battery output. The submarine could make 12 knots underwater on battery power alone, 3 times faster than earlier boats, though still slower than surface vessels. But that speed underwater fundamentally changed the tactical calculus. A conventional U-boat, when detected, faced a choice between diving and accepting limited underwater speed, or remaining on the surface and risking air attack. The Type 21 could dive quickly and still move fast enough to evade or reposition. It could run down the bearing of an approaching convoy and attack from angles previously impossible. Yet this advantage only mattered if the submarines actually made it to operational patrol areas, and by the time they were ready, the waters they would have hunted in were controlled by Allied anti-submarine forces that had grown formidable in their competence. The crews must have felt something like the weight of prophecy unfulfilled, preparing themselves for battles that might never come, learning to operate machines that represented the apex of German submarine engineering, at a moment when that engineering could no longer affect the course of the war. And yet there was something also oddly noble in it, a kind of stubborn persistence in the face of overwhelming circumstance. They trained because training was what you did. They learned the Type 21's secrets because knowledge was what kept you alive. The sense of futility that must have haunted many of them did not manifest in a collapse of discipline or a refusal to engage. Instead, it seems to have created a kind of quiet resignation, a determination to be as prepared as possible for whatever might come, even if what came might be nothing at all, or might be too late to matter. The winter of 1945 found many of these crews still in training, drilling in the Baltic or the North Sea, moving through the choreography of submarine operations in waters that were themselves becoming battlegrounds. The Soviet advance from the east was bringing the war closer to the German shipyards and training facilities themselves. Some crews and their boats began to be dispersed to less vulnerable locations. Others found themselves in a kind of limbo, too advanced in their training to be held back for further instruction, but not yet assigned to any specific operational command. The machinery of the German Navy was winding down, its purposes becoming confused and contradictory. The Type 21 represented a certain vision of what naval warfare might have been, had it arrived 5 years earlier, had the war continued 5 years longer, had the Germans possessed the industrial capacity to build them in the hundreds rather than the dozens. But none of those conditions obtained. And so the crews trained on, in the gathering darkness, preparing for a future that was dissolving around them even as they prepared. The final months of the war drew closer with each passing week, and yet the Type 21 remained caught between ambition and reality in ways that few observers at the time could fully comprehend. The boat had been conceived as a savior, engineered as a revolution, yet the machinery of its own creation was grinding against the inevitable forces of collapse. By early 1945, Germany's industrial capacity was fragmenting across multiple fronts, and even the most meticulously designed submarine could not outrun the mathematics of defeat. The yards that built the 20th were now under threat from bombing campaigns that had become almost constant, and the supply chains that fed those yards were severing one by one. What had once been a logistical achievement of considerable magnitude, coordinating the construction of dozens of these advanced boats simultaneously across different shipyards, became an increasingly desperate improvisation. The crews assigned to the Type 21, when they finally began arriving, found themselves in an odd and unsettling position. These were sailors who had trained on older, proven boats, submarines whose characteristics had been refined through years of operational experience. The 25 was fundamentally different in almost every meaningful way, yet there was minimal time for the kind of extended trials and familiarization that such a radical design demanded. Imagine learning to pilot an entirely new aircraft with only theoretical knowledge and a handful of rushed hours in the cockpit, knowing that your first real flight might well be your last. The psychological weight of that situation manifested in different ways among different men. Some approached the assignment with something approaching hunger, viewing the XP sign as the weapon that might finally shift the calculus of the Atlantic. Others carried a quiet dread, understanding that this was a machine that had never been truly tested, and that they would likely be among the first to discover its flaws under conditions of genuine combat. The training process itself reveals something profound about the desperation of the moment. Normally, introducing a new weapon system into military service involves extensive ground testing, simulated trials, and graduated deployment with close monitoring and adjustment. The Type XXI was given none of this. Instead, crews would conduct basic familiarization runs, sometimes lasting only a few days, in the Baltic, a relatively protected body of water where the threat of enemy attack was minimal compared to the Atlantic. These exercises covered the essentials, learning the layout of the boat, understanding the operation of the new systems, getting accustomed to the slightly different handling characteristics. But they could not and did not adequately prepare the men for what a submerged combat engagement would truly demand of them. The sonar operators needed to understand how the acoustic systems would perform when tracking a real target, not a practice exercise. The engineers needed to know how the boat would respond when running at maximum depth under conditions of genuine enemy pressure. The captains needed to develop an intuitive sense of tactics specific to this new design. One aspect of the 21's operational preparation that historians have often overlooked involves the question of doctrine. How should a boat this fast, this quiet, this fundamentally different from everything that had come before, actually be employed in combat? The traditional German U-boat tactics, developed through years of experience with slower diesel boats, involved the captain locating a convoy through surface reconnaissance or radio intercepts, maneuvering to an attack position, and then launching a salvo of torpedoes before diving to escape the inevitable counterattack. With the Type XXI, new possibilities opened up. The boat could detect targets underwater at considerable range through its superior sonar. It could approach at speeds that would have been unimaginable for earlier designs. Theoretically, it could attack from deep below the surface, striking before the target even knew it was there. Yet these theoretical advantages had not been tested in actual operation, and there was no time now to develop and refine the tactics that would maximize them. The question of how to arm the Type 21 also occupied considerable attention during this period. The boat was equipped with 4 bow torpedo tubes, a significant increase from earlier types. and these would be its primary armament. But which torpedoes should it carry? The standard acoustic homing torpedo, the NAT, had shown promise in earlier models, but it was still somewhat unreliable. There was a newer variant under development, but these were not yet available in quantity. The decision was made, with some reluctance on the part of the naval establishment, to equip the early XXIs with conventional straight-running torpedoes, essentially the same weapons that had been used throughout the war. This represented a significant underutilization of the boat's potential. A modern submarine with advanced sonar and superior speed was being sent to war with weapons that had not fundamentally changed in years. The disconnect between the platform and its armament speaks to the fragmented nature of German war production at this late stage. There was another consideration that weighed heavily on the minds of those responsible for the Type XXI program, though it was rarely discussed openly. As the boats neared completion and crew training accelerated, it became increasingly clear that time was not a luxury Germany possessed. The war in Europe was entering its final chapter, though the exact length of that chapter remained unknowable. If the 20 fine was going to have any impact whatsoever on the course of the conflict, it would have to become operational quickly. This created a terrible pressure on every aspect of the program. Inspections had to move faster. Trials had to be compressed. Training had to be abbreviated. The traditional safeguards and verification processes that normally accompanied the introduction of a new weapons system were being bypassed out of sheer necessity. One might wonder whether this acceleration ultimately served the program well or ill. Did rushing the boats to sea result in the loss of vessels that should have remained in development, or did it at least give them a chance to gather operational intelligence that might have proven valuable had the war continued? We may never know with certainty. The human cost of this compressed schedule was borne primarily by the crews themselves. Young men, many of them not yet 25 years old, found themselves aboard a revolutionary submarine that was still discovering its own characteristics, under the command of officers who were often equally unfamiliar with the boat's capabilities, all while the strategic situation grew darker by the week. The submarine service had always been dangerous, but there was something particularly poignant about the position of these early Type XXI crews. They were not veteran submariners with years of experience and accumulated wisdom. They were part of a generation that had been at war since childhood, that had grown up with these weapons as simply the world they inhabited. Many of them had already experienced combat in earlier boats. Some had survived sinkings. Now they were being asked to trust their lives to a machine that was still, in many respects, experimental. Letters and diary entries from this period, when they survive, reveal a curious mixture of emotions. There is pride in the technical achievement, a sense of being part of something genuinely innovative. There is also, often enough, a quiet skepticism. These men understood boats. They understood the sea and its dangers. They had learned, through experience, that revolutionary designs often came with revolutionary problems. Yet there was also, it must be said, a grim determination. By early 1945, few German servicemen retained much hope that their nation could achieve victory. But there remained a sense that one might at least do one's duty, might at least ensure that Germany's enemies knew they had been in a fight. The Type XXI represented a final opportunity for the submarine arm to make that statement, and there was something almost poignant about the way in which crews embraced that mission, even as they harbored private doubts about the vessel's reliability and their own chances of survival. By the spring of 1945, the fate of the Type XXI had already begun to crystallize into something far more tragic than any single technological failure could explain. The boats themselves, by this point, were emerging from the shipyards with increasing frequency, their numbers climbing toward that theoretical operational force that Berlin's planners had once dreamed would turn the entire Atlantic into a German lake. Yet each new hull that slid down the ways and into the water represented, in a very real sense, the last gasp of a nation already suffocating under the weight of its own collapse. Picture, if you will, the peculiar agony of German naval command in those final months. They possessed, On paper, the most advanced submarine design in the world. The technical achievement was undeniable. Every specification that mattered to a modern submarine captain, the speed, the endurance, the revolutionary snorkel apparatus, the streamlined hull that promised to transform underwater performance, all of it was there, tangible, real. And yet that promise had become something closer to a curse, because the boats were arriving faster than they could possibly be crewed, faster than their captains could be trained, faster than the fuel reserves could be secured to send them to sea. Consider the strange paradox that haunted the Kriegsmarine in these final days. The more boats that were completed, the less capable the Navy became of actually employing them. There were simply not enough trained personnel, not enough experienced officers who had survived the Atlantic to teach younger men how to survive it themselves. The institutional knowledge of the German submarine force had been steadily hemorrhaging away for 3 years, lost in the depths with the men who carried it. Some historians suggest that by 1945, the average U-boat commander had perhaps 6 months of operational experience at best. The Type XXI required not just technical competence, but an almost intuitive understanding of the boat's capabilities and the sea's moods, a kind of sixth sense that could only be developed through long exposure to danger. There were other pressures too, ones that operated in the quiet spaces between official reports. Supply chains had fractured. The German synthetic oil industry, once the envy of European engineering, lay in ruins. Refineries that had supplied diesel to the fleet were now twisted metal and ash. What fuel remained was rationed with the careful parsimony of a doomed man counting his final coins. Some Type XXIs were being fitted with alternative propulsion systems, experimental configurations that seemed promising on the drawing board, but which no one quite trusted in practice. Others sat in their bunkers, completed but unfueled, awaiting a supply that would never come. The question that occupied German naval planners with an almost obsessive quality was this: could they get even a handful of Type XXIs to sea in meaningful numbers before the Allies closed the final door? Admiral Dönitz, still commanding the fleet though his authority had become increasingly nominal as the Thousand-Year Reich crumbled around him, pushed for an accelerated deployment schedule. The boats that were ready, truly ready, not merely structurally complete, should be sent out, he insisted, to at least engage the enemy, to perhaps prove that the theoretical superiority of the design could be translated into actual success. But there was a terrible logic working against him. Every Type XXI sent to sea prematurely, crewed by insufficient personnel with inadequate training, operating with questionable fuel reserves, was quite likely to be lost without achieving anything meaningful. And yet to wait for perfection, for complete crews and full supplies, was to guarantee that the war would end before any of them sailed at all. It was a choice between two varieties of defeat, and it gnawed at the men making it. The final operational sorties of the Type XXI came in the absolute closing weeks of the European War, when Germany's military situation had moved beyond desperate into the realm of pure fantasy. These boats, when they finally did leave their bases, encountered an enemy that had learned to see them coming. The Allies, after 5 years of bitter struggle against the U-boat arm, had developed technologies and tactics that were devastatingly effective against submarines of any kind. Sonar, radar, improved depth charges, and coordinated hunter-killer group tactics, all of these had been refined to a razor's edge. What happened to those early Type XXIs that made it to operational stations is instructive precisely because it was so anticlimactic. They encountered Allied naval forces that treated them with a kind of weary efficiency. The advanced design that was supposed to change everything often made little practical difference against an opponent that had trained for years against such threats. The boats that operated in the final weeks of April and early May 1945 did manage to sink a few vessels, modest accomplishments measured against the grandiose claims that had been made about what the Type XXI would achieve. A few Allied ships went down, their crews lost to the sea, small tragedies that barely registered in the larger catastrophe of Germany's final collapse. One might wonder, listening to this, whether the Type XXI was truly the revolutionary weapon its designers believed it to be, or whether it was ultimately a technological answer to a problem that had already become political and existential in nature. Perhaps the submarine, no matter how advanced its design, was simply incapable of reversing the enormous material superiority that the Allies had achieved by 1944 and 1945. Perhaps the war had already been decided in places far from the ocean, in the skies over German cities, in the factories of America, in the calculated arithmetic of production statistics that had always favored the Allies and would continue to do so regardless of any single weapon's design. What remains certain is that the Type 21 never had the opportunity to prove itself in anything resembling ideal conditions. The boats that did achieve operational status were dispatched into circumstances so unfavorable against an enemy so thoroughly prepared and with crews so inadequately trained that any assessment of the design's actual combat potential becomes almost impossible to make with confidence. It stands in history as a monument to what might have been had Germany possessed the resources, the time, and perhaps most importantly, the strategic vision to have developed it years earlier, when the sea was still a place where submarines could operate with something approaching autonomy. The last Type XXI U-boats to be deployed were sent out in the final week of the war, in some cases with orders to conduct suicide missions or long-range cruises to distant waters where they might continue the fight, even after Germany surrendered. Some of these boats never even reached the open ocean. Others sank en route, lost to weather or mechanical failure rather than enemy action. A few survived the war itself and were captured by the Allies, their pristine hulls and revolutionary designs providing the victors with the opportunity to study in detail exactly what German engineering had managed to achieve in those final desperate years of industrial effort. And so the Type XXI remains, in the end, a machine that lived in two worlds simultaneously, one real, one imagined. It was born into history at precisely the moment when history had already decided its fate, and perhaps that collision between ambition and inevitability tells us something deeper than any technical specification ever could. The submarine that was meant to change everything instead became a monument to the very question it was designed to answer. How much can engineering overcome when time itself has run out? Consider the weight of what almost happened. Had the Type 21 entered service 18 months earlier, had German naval strategy shifted just slightly, had the industrial apparatus operated with even marginal efficiency beyond what it actually achieved, the arithmetic of the Atlantic might have rewritten itself. Ships would have sunk that were not sunk. Convoys would have been scattered that managed to arrive. The supply lines that fed the Allied war effort might have grown thin enough to matter in ways we can now only wonder about. Yet none of this occurred, and there is a peculiar kind of peace in accepting that, a recognition that history, despite all its branching possibilities, follows certain grooves deeper than we often admit. The men who built the Type 21, those engineers and workers in the shipyards and design offices, they were operating on conviction. They believed their creation would matter, and in a way, it did, just not in the way they hoped. Instead, it mattered as a whisper of a future that would never arrive, as proof of concept for technologies that submarine designers would spend decades studying after the war's end. The Allies captured vessels, studied their hulls and their propulsion systems, and took careful notes. The Soviet Union, watching from its eastern vantage point, saw in the Type 21 an image of what undersea warfare might become. The Americans, the British, the French, they all learned from the ghost of what Germany had tried to accomplish. In that sense, the Type 21 did change the world. It simply took decades for that change to unfold, and it happened not through German victory, but through German defeat, and the knowledge that defeat left behind. There is something haunting about technological ghosts, machines that might have been, designs that represent roads not taken. The Type XXI is perhaps the most famous of these spectres from the Second World War, but it is not alone. Throughout history, innovation and tragedy have danced together in this way, creating artifacts that become almost more powerful in their unrealized potential than they ever could have been in actual use. We gaze at them and ask not merely what they were, but what they signaled about the human impulse to engineer solutions, even when time forbids their deployment. The Type 21 whispers that the mind's reach can exceed circumstances, that brilliance can exist, trapped in amber, waiting for a war to end before it can truly be studied. The final patrols of those few Type 21 boats that did make it to sea carry their own quiet weight. The crews who manned them understood, perhaps without fully articulating it, that they were sailing machines designed for a war that was already ending. They carried within them the hopes of German naval engineers who had poured everything into their design, yet they also carried the foreknowledge of defeat in the very speed and silence that made them remarkable. There is a kind of melancholy in that contradiction, the sense that excellence and futility can occupy the same hull, the same moment in time. Some of those boats were scuttled by their own crews rather than surrendered. Some were used briefly in the war's final days, and then fell silent. Others were towed into ports in triumph, examined like relics, their secrets slowly unpacked by victorious powers. And somewhere in that transition from weapon to artifact, from instrument of war to historical object, the Type 21 became something else entirely. Not a failure, exactly, but a question posed to future generations. What does it mean to create something beautiful and terrible if circumstance denies you the chance to deploy it meaningfully? What weight does ambition carry when time runs out? The engineers who designed the Type 21 did not live to see nuclear submarines cruise beneath polar ice caps, though their work helped light the way toward that future. They did not witness the arms races and the proxy wars and the vast underwater fleets that would populate the Cold War. Yet their innovations, the streamlined hull, the schnorchel systems, the approach to battery efficiency, echoed forward into decades they would never see. In this way, even technological defeat becomes a kind of immortality, a sending forward of knowledge into an uncertain future. The Type 21 sank beneath the weight of history, and yet it did not truly disappear. It transformed instead into something more permanent, into lesson, into inspiration, into the genetic code of all submarines that followed. Perhaps the deepest truth about the Type 21 is that it was simultaneously too late and far too soon. Too late to change the outcome of the war it was meant to win, yet far too soon to fully realize the implications of what it represented. The submarine warfare of the Atlantic would have been different if these boats had been ready in 1943 instead of 1945, yes, but the submarine warfare of the decades ahead would have been impossible without the knowledge they embodied. History often works this way, in paradoxes that only become clear in retrospect. We build something extraordinary, we fail to use it as intended, and then we discover that its truest purpose lay somewhere we did not initially foresee. The silence of the Type 21 is perhaps its most eloquent quality. These boats rested on the ocean floor or sat in ports, their engines quiet, their torpedoes never fired in the numbers their designers imagined. That silence is not absence, though. It is presence of a different kind, the presence of might have been, of roads not taken, of the infinite branching possibilities that history constantly forecloses. When we think of the Type 21 today, we are thinking not merely of a submarine, but of all those parallel worlds it never inhabited, all those outcomes it might have produced had circumstances aligned differently. That is why it endures in our imagination. It is the perfect embodiment of the contingency of history, of how fragile the moments are in which great events turn one direction or another. As we move further away from the Second World War, the Type 21 becomes less a weapon and more a mirror in which we contemplate our own present moment. It reminds us that innovation and intention do not guarantee outcome, that brilliance can be overwhelmed by circumstance, that history moves according to rhythms only partially determined by human ingenuity. The men who served on those boats, the engineers who designed them, the workers who assembled them, They are all long gone now, but the questions their story raises remain alive and urgent. What does it mean to build for a future you will not see? What is the relationship between technical excellence and historical timing? How do we measure success when circumstances deny us the chance to realize our designs? These are the questions that carry the Type 21 forward into our contemporary moment, and they are questions without easy answers.